Hello, welcome to the Python Flask tutorial series. In this video series, we'll learn how to build web applications using Flask, a micro web framework written in Python. So, during the course of this series, we'll understand the concepts in Flask while developing a project. So, before we get started with the project, let's talk about what is Flask. Now, here I have the official documentation opened up. So Flask is a lightweight WSGI web application. WSGI is the Web Server Gateway Interface. It is a specification that describes how a web server communicates with the application and how web applications can be chained together to process one request. Now, at the beginning of the video, I said that Flask is a micro web framework. So, what does micro mean? Now, micro does not mean that your whole application has to fit into one single Python file, although it certainly can, nor does it mean that Flask is lacking in functionality. The micro in micro framework means Flask aims to keep the core simple but extensible. Flask won't make any decisions for you, such as tell you which database to use. Those decisions that it does make, such as which templating engine to use, are easy to change. So you can think of Flask as a plug and play framework where you can plug multiple different libraries to it depending on your preferences and your suitability and develop your own web application. Now let's see what kind of web application we will be building during the series. We will be building a web application called Pushups Logger, which can be used by anyone to log their workouts. So this is how the website looks, the homepage. We have a lot of functionalities here which we'll be building from scratch. As you can see, it is a minimal clone of Pushups Logger, which is a very famous website to log your pushups, as you can see. So we'll be developing this where users can log in, sign up, add a workout, and also view all their workouts as time progresses. So let's see how the website, how the final product looks like. So this is the homepage, as you can see. You can go to sign up, add a name, let's say John Doe, and johndoe@gmail.com and johndoe123. You can sign up and then log in, johndoe@gmail.com, johndoe123. Yes, so now a user John Doe has been logged in. You can view all of his workouts here, but we haven't added any workout, so there are no workouts for now. So let's add one. So let's say John does around 25 or 30 push-ups in one sitting, one workout. He's very fit, and he says that I wasn't sore and it was a good workout. I feel great now. And he adds a workout, so the workout has been added. Now that he's added a workout, we can go to all workouts and see the workout which he has added. And now we have an option to edit and delete the workout as well, or John does. So let's go and edit the workout. So let's say he miscalculated the push-ups. He did around like 29, and he said, and the comment can be the same. I wasn't sure. It was a good workout. I feel great now. Next target is 30. And we can update the workout. And now when he wants, he can also delete the workout, as you can see. So this is how the website works. We'll be adding a few functionalities later where we can visualize graphically the workouts and also set up a leaderboard, but that is going to be a much complicated tutorial. But in this series, we'll make the simple website called a Pushups Logger, which implements basic CRUD functionality, which is create, update, and delete. So you can create a workout, edit the workout, or update the workout, and also delete it by talking or communicating with the database. And we also have user authentication functionality where you can sign up, log in, and also log out. So this is a very simple basic web application which we'll be building together during this web series from scratch. So let's get started. So in this video, we'll just install Flask and make sure that it is up and running. And from the next video, we'll start developing the web application. So make sure that you have Python 3.x, any version of Python 3 on your laptop or on your PC. And let's go ahead and install Flask. So first thing, make go to any of your project folder and any folder you want. I would say make a new folder on a desktop called as push ups logger and go inside that. So we'll be adding all our files inside this push-ups logger, every single file which is associated with the web application. And now let's install Flask. So as I said, you need to have Python 3, any version of Python 3 on your laptop or PC. Pip3 install Flask is the command. And since I already have it, it shows that it's already satisfied, but you should be able to see it downloading. And once it is installed, we can make sure that it has been installed by importing it inside our interpreter. So import Flask, and yeah, I'm sorry about that. Yes, so we have Flask up and ready in our PC or laptop. And in this video, we'll set up the base and develop a hello world using Flask, and also see how our directory structure or how our folder for Flask application looks like. So just before we start coding up our web application and also start the basics of Flask, let's just see how the final web application looks like again. So this is how it looks like. We are going to make a push-ups logger to implement basic functionalities for web, which is one, CRUD, create, update, and delete, where users can create or add new workouts, update the workouts, and also delete them. This is the idea is similar to what the Flask documentation provides as a tutorial, which is making a blogging application. So since all the tutorials on the internet are about making a blog using Flask, I have just made a few changes in the idea where instead of writing a blog, you log your push-ups or workouts, because during this quarantine, I need something to track my workouts, and this is a very simple idea to do so, and also helps me learn about Flask much easily. The second thing is user authentication, where you can add or sign up as a user and also log in, track your own personal workouts, and then log out. So this is what we'll be building. This is how the final application looks like, and we'll be developing the entire thing from scratch. Now let's get started. Let me just close my application, the one which we had made. So in the previous episode, we made a folder inside our directories, where inside this folder we'll be having all of our files. And let's just see, we are there. Okay, so we are inside that, or just one structure before that, and let's open this up. So I've opened this up using VS Code, but you can use any uh, code editor or text editor you want to use. I'm comfortable with VS Code, so I'll be using that during my entire tutorial. So uh, we see here that we can just develop something called as a hello.py application file, where we just directly code up our application and start the server running. But since this is not going to be your just a very basic Flash tutorial, we'll be actually developing a project. So we'll be doing everything in a way a project should look like. So we'll be having files which only handle user authentication. We'll have files which only handle the create, update, delete functionality, and everything will be fragmented and like a professional project which you can put up on your resume. So we'll not be following the usual way how Flask applications are built. There's nothing wrong with this. This can be completely done. As a Flask says, it offers suggestions, but it does not force anything on you. It is not opinionated. So you can make your Flask applications any way you like. I'll be showing it the way I prefer it, or the way I am comfortable using it, because it helps me debug the errors pretty quickly. So, and during the course of building the web application, we'll be going through some concepts in Flask, which we'll be talking about. So let's get started. So the first thing, instead of making a hello.py, we'll be making an init.py. So let's just go ahead and make that first, and then we can talk about how to do it. So let me just set up my VS Code again. It's throwing in some errors. That's fine. And go back. So we'll talk about why we went back to our parent directory and not inside this in a second. But let's start. Let's make a new file, init.py. It has two double underscores before and after the name. And this is going to be the first file in the project that runs whenever you run the project. So whenever you run the project, this is the first file that is going to run. That is why it's called the init.py, or the initial file that runs. Don't worry about the .vs code folder here. It only deals with the environment I'm using and other such basic functionalities, and only focus on init.py. So let's first import Flask. So from Flask, import the Flask class. That is the first thing which we do. Next, we are going to make something called as a create app function. So this is a function for which the name has to be create app because it is given by Flask. We're going to override that to make our own application. So first, let's make an instant of our application. So app is going to be Flask, and the name parameter, which is going to be the name of our project, which will be if not related. And we're going to just return the instance. So this is a very simple basic structure of our application. We cannot run the application yet, but this shows how to import Flask and create an application using init.py. Every project which becomes very complicated as we go requires fragmentation and dividing them into different files which handle each feature singularly. So init.py will deal with everything that has to be set up only once. So setting up the instance, we'll be doing that only once. We'll be setting up the database once, and also the login features at once for each instance. So all the user ID codes and setting up the database, the code for that will be inside this init.py file. And now let's go ahead and set up the main function. So let's start by setting up the directory structure. So what we have two functionalities. We have CRUD, which is create, update, delete functionalities, and we have our authentication functionality, which is logging in a user, signing up, logging out, etc. So we need two files. One which handles the create, update, delete, which is the main feature. So we'll call that main.py. And the second thing which we want is for authentication. So auth.py. So these two files will be main.py will be handling the create, update, delete, or showing the home page and the profile page, all those sorts of features. And auth.py will deal with logging in and how to log in, how to sign up, etc. Let's focus on main.py and set up our hello world for now. So let's import Flask. Let's use Flask to import some basic things which we need. So we need something called as blueprint, which we'll talk about in a second, and render template. So first, we're going to initialize this main file as a part of our Flask application. So main equal to blueprint main and the project name, which is name. Now, what is blueprint in Flask? So blueprint is a way to actually organize your files inside a Flask project. So I want my Flask structure to know that everything inside main has a name, main blueprint, and all the files and all the functions inside this file will be accessed through the blueprint for main. So if I have an index function, if I have a profile function which handles all the profile information, I can access that anywhere in the Flask structure using main.index or main.profile. So I'm setting up a blueprint for my Flask project, and for that, Flask provides you a blueprint function for you to do so. Now we need a decorator for every single Flask uh, function we make. So we have the main, because we have a main blueprint here, and we route it to home. So this is a decorator which overrides some functionalities for your own application. I'll give you a link down below to understand how decorators work by this YouTuber called as Korisha Fair. He has a tutorial on Flask, on how to build a blog using Flask, and also how decorators work. So let's make up our index function, or the home, and just return hello world for now. And we have our hello world ready, but it's not quite done yet. We want our application to talk or communicate with main.py, right? We want our application to find something called as main.py when the application runs. So the first file which runs when you run the project is init.py, right? So let's communicate with main.py using something called as register blueprint. So we go to from dot main. So this is where our main file is. We import main, which is the name here. We import this instance of the blueprint, and this is a main blueprint. So let's give it a name for readability. We'll be focusing on code readability and following good practices along the way. So make sure that you do that as well. And let's register our blueprint. So we use register blueprint and main underscore blueprint. Now we have registered our blueprint and we can run the hello world application, but we'll just go one step further and make sure we have all our functions ready. So this is going to be our main function, or the home page for our website. And now we'll go and set up a profile link. So main.route is going to be profile, where we can see the profile of a person, and we'll call it a profile as well. And let's just return something called as profile here for now, and we're good to go. Now we have very simple basic functionalities ready here, which is the home page and the profile page. And let's set up the authentication routes as well. So sorry about that. From Flask, import blueprint. Again, we have to have an authentication blueprint as well, and render template. We'll talk about render template in a minute, how to actually show HTML pages using Flask. But for now, let's set up our auth blueprint. The name is auth as the name of the file, and the name of the project, which is by underscore name. Now we'll have an auth route here, or dot route, and we need something called a sign up first. Define sign up, and for now let's just return something called as this page will be used to sign up users. And now after signing up, they have to log in. So let's make a login page. Again, auth.route, and my bad, it has to be after a slash. That's going to be a next page, login, and let's return that this page will be used to log in users. And just give it a full stop because I want to. And now that users have signed up and logged in, the next thing which they can do is log out. So let's give them a way to do this as well. So use this to log out. For now, we're just printing text on the web page, nothing else. We haven't started printing HTML pages yet. We'll do that in a minute. For now, we'll just print up text messages on the screen, because we're going to set up a hello world for now, and also set up the directory structure. So as you can see, we have two files: main, which talks about the main features, which is create applications, which we'll talk about in a minute, and also the home file and the profile. And we have the auth page, which deals with only signing up, logging in, logging out, etc., etc. So yeah, I think we're done. Now we have to make the auth.py page communicate with the project. So we do the same thing here as we did for main. From .auth import auth as auth blueprint app.register blueprint auth, and now our application is ready to run, to just run a hello world application. So before we do that, I'll be skipping some concepts here, some explaining some pretty simple Python concepts. So make sure that you have some experience with Python before you jump on to building web applications using it. So I'll be skipping some Python concepts. For example, dot main. What does dot main mean here? So dot means the current structure, the current place in the tree. So dot is where all the init auth main files are on the same level, and main is the file which is inside of that structure, so main. So dot main is that. So such simple concepts which I will not be explaining, which you can just go ahead and Google search it. So yeah, so let's just make sure that everything is correct and in the place. So init.py runs your file, the first file which it runs. We create an instance of a Flask app. We connect our main.py page and our auth.py page and return the app. We'll talk about why it has to be named create app only in a minute. We have main.py, so we set up the main blueprint. We haven't used render template yet, but we will be using it in some time. We have our routes, so first the home route or just slash, which is hello world. Again, we have profile where we can see the profile. In auth, we have a sign up, login, and logout. Now let's see how we can run this project. So go to your uh, terminal or a command prompt, see where your folder is. So inside this folder, we have our files, but go back a bit and type this. So export Flask app equal to your folder name. So push ups logger. So what just happened? Why did we do this? So explode Flask app is an environment variable, a Flask app, which is given by Flask when you pip install Flask, and this sets up the behind the scenes for you, how the WSGI or the web server gateway interface works, how to run the application. So usually you just create a app.py file or hello.py file, not an any.py, and you have this functionalities there. But since we are going to set up a entire project, we have our project name pushups logger, and Flask automatically looks for the create app function inside init.py and sets up everything for you. So now all you have to do is to Flask run, and your website will be running. And we can go to this point and see whether it's running or not. Yes, as you can see, we have hello world here. Then let's go to profile and see what happens. So profile is here. We have sign up. So again, just to sign up and log in and log out. Yes, so our website is up and running. Perfect. My debug mode is on, so there is a way to do it. We'll talk about this in the next video, how to have a debug mode on. What does a debug mode mean? But for now, let's just skip this. You might not have this debugger message here, but go with it now. Close the application using Control C only, because we have to close the port 5000 when we do it. And now let's see what render template is all about. So render template is used to actually show up HTML files using Flask. And how do we do that? So first we need a folder with name templates. The name of the folder has to be templates. Inside that we need some files. So we need let's say index.html for our main file. We need login.html. We need sign up.html, and we don't need a logout.html for now. We'll talk about that later, for why don't we need a logout.html, because we don't show a page for logging out. We just click a button and it logs us out and sends us back to the index.html file. So yeah, now we have our templates ready, and let's actually set up profile again, profile.html. Now Let's render them, or let's just write some really simple functions. So home page, then sign up will have a sign up heading. Simple heading is to make sure that it works. Log in and profile. So now let's render them. So to render them, we use when we return something, we return the render template and the name. So index.html. We do the same for all the other return values. So this is going to be profile.html, and for auth, this is going to be sign up, and for login, it's going to be login. Yes, so now we have set up our HTML files, and we have our basic uh, render template functions ready. Let's use them now. You use Flask run, and everything is working properly. Let's go to the home page again, and as you can see, the h1 tag has been rendered, so the HTML is working with your files. So this is how we make a hello world in a project manner, not a simple hello world, but how we can do it for a project. So we have our init.py, which is the first file that runs when you run the project, when you do Flask run. It sets up your Flask instance behind the scenes. It registers main, so that is where you can see the main functions and also the auth functions. We have used Blueprint to do that, and to render the templates for HTML, we use the render template function. And we just printed the hello world for now, but in the next video, we'll set up more. We'll talk about what is Ginger templating, how to set up Bootstrap, etc., etc. In the previous video, we talked about how to set up our hello world and the project file structure. So we created an init.py, which is how we set up our Flask instance. We also talked about blueprints, which we can use to handle our files in a Flask directory. We also talked about how to render HTML files using templates in Flask. So today we'll actually build more of our application, and we'll also look into templates and Bootstrap and how we can use this both to build some components of our website. So let's get started. Before we start our next step, I just want to let you know that I have made a static folder. So a static folder in Flask contains all the static files, so static CSS files, images, fonts, etc. of your project. So make sure you have the static folder ready with images and some CSS, which we'll be using in a while. These CSS files only have the fonts and etc. Nothing important for Flask. We'll be using these in our late HTML code as well. So let's get started. So now when we want to build our push-ups logger application, what we notice is that it has a navigation bar, which has the workouts, signing in, logging in, the profile page, etc. And what we notice is that the navigation bar is common for all the HTML pages. So it is common for the profile page, the home page, to add a new workout, to log in, sign up. The navigation bar stays the same because, well, you have to navigate through it or using it. So now, instead of writing the navigation code for every single HTML file again and again, what we can do is use something called as template inheritance in Flask, where we can set up a base template with some HTML code and use that code again and again, or inherit that template for other HTML files. So a perfect example is what we are going to do here by using a navigation bar. The code for the navigation bar is going to be constant across all the HTML files. So we'll just set up a base template using that HTML code. So let's see how that works. So let's create a base.html file inside templates. And this is some code I have already written for having the navigation bar using Bootstrap. So you can go ahead to this website. The link will be in the description to download the Bootstrap CDNs and include these links in your header tag. And for the navigation bar, I have referred to the navbar documentation of Bootstrap and modified this particular navigation example and use that in my code. So we'll be making some changes into this right now. How to connect our static files to this. That is one important thing which we need to talk about. And also what these block head and block content mean. So now we have this base.html file and we have to connect this with other HTML files. But before that, let's actually make this a complete HTML complete file where we have these empty tags. So now we want to link our static files with our HTML files, and a good way to do would be just to say static and go to our files. But in Flask, we can do it in a different way, in a much more Pythonic way, which people prefer and developers prefer. Where we'll be using something called as URL for. So URL for is a function in Flask which you can use to generate dynamic URLs. So for something like some static files, it is not required, but it is preferred to do so. But when we have dynamic URLs, for example, when we create a new workout and we want to see that new workout, or edit that new workout, the workout will have its own ID. And when we have to generate that during runtime, when a user is using it, we use the URL for's capability. But just to keep the entire code consistent and not use different tactics and different features, we'll be going for URL for every single endpoint which we need. So let's import URL for first in both the auth and main, because they will be using it. And now we can actually use Python code inside our HTML pages by using something called Jinja templating. And this is how it looks like. So any statement under a curly brace and a percentage sign will be a control statement. For example, for loops, if statements, blocks, etc., etc. And anything between these two will be a statement. For example, a variable name, initializing a variable name, or printing something. So we can use these to actually talk to our HTML file using Python, or use Python into our HTML files. So now that we have our URL for function, let's actually use that into our sign up, login, etc. pages via base. So now let's give it two statements because it is statement and URL for. Now, how do we link it to the static files? So the syntax is that we are going to go to static, and then we're going to do file name, and the file name is this. So it is a favicon. So favicon is inside images. So we're going to go inside images slash muscle.ico, and that is how we have a URL for. We have the static folder first. URL for automatically looks inside your directory structure, looks for static, goes inside images and takes up muscle ICO. Use the same concept for linking our CSS files. So same static, but instead of this, we have our CSS file, which is beauty.css, if I'm right. Yes. And let's see if we have to use it somewhere else as well. So now we want our pushups logger tag should always point, when we click on it, to point to the main or an index page, right? So the index page is here, and the name of the function is index, and it's the main's blueprint. It comes under the main blueprint. This is how the syntax will look like for this. You don't have a file name here, so we remove the file name completely. We just have a URL, and just go back. I think I made a mistake here. Oh yes, we have a comma and a comma. The file name is a parameter for the URL for function. And here, instead of static, we have main.index. So this is how we actually refer to the pushups logger index page using main. So it's very easy to now keep track of all the routes. So we have a main route, a main blueprint inside which we have index. Similarly, we want to go to all workouts. So all workouts is also under the main page, which will be adding in a bit. And it will be having all workout, but let's just give it index for now because we haven't made this yet. Then we have the account, which is going to be the profile. So main.profile, and we go to sign up. So sign up comes under auth now. So instead of main, we have auth.signup. And similarly for login, we have the same thing. So we have URL for auth.login. So as you can see now, using blueprints, we are able to really we are able to write the code very easily and very intuitively, where we can clearly understand that this is under the main blueprint, under main features, and these come under the auth features. So now that we have written the base.html, let's see how template inheritance works and how we can actually add this to our other pages and just inherit from the base. Let's go to index first. This is how the syntax looks like. We have a control statement, and it extends from what? Extends from base.html. So now that we have added extends from base, everything from base should be under this. But I would like to change some CSS files here because I need to use this later. So let's see how we can actually override our head to add some CSS files. So now we use the block control statement when we have to override something from our inherited template. So here I have a block head for the entire head tag, and let's again use that tag here. So we have block head, and now we want to inherit everything from the head tag except the CSS file, or actually override the CSS file. So we have to inherit everything, right? So we just write that we are inheriting everything from the main base, so inheriting from super. Then we add our own CSS file. So I'll be linking here, and we want the extended beauty here. So let me just go back and copy the code for adding the link. So here we have our static, and the file name is extended .css. When you have more than one file, it is recommended that you have a CSS folder, and then use that folder. But since I have only 2 files, I won't have a folder for them. And now that we have finished it, we have to end our block. So we end block for our head. So in this way, we were able to override the extended beauty, the beauty CSS file into our index by extended, and also extend the base. Now I want this on all my files, so let me just copy this into login, profile, and sign up, so that all of these have the same functionality. And yeah, so we're good to go now, and let's see how this looks like. So go to Flask, run, make sure we are inside, sorry about that. So we are in the video 3. So when I go into video 3 templates, this is all my files here. So go back, write export Flask app, and the name of your folder, which is PL video 3 templates for me. It can be just the push-ups logger name for you guys, and just type Flask run. And the server is on now. Let's see what we have here. And as you can see, we have our nav bar ready. And when we go to all workouts, the same thing. When you go to sign up, we go to sign up here, and the nav bar is still the same for login as well, and for profile. So now our nav bar is done, and we can go ahead and start filling our application with other content. So let's go ahead and do index now. So now in the base, when you scroll all down after the nav bar, we have a block content where we can actually add our content here. So I want to add content here in between, so I'll be using the same tags for my index page. Sorry about that. So now go ahead like this, and this is going to be down all the way, and we add our content here. So first I need a hello, so welcome to the page, so hello. After that, I'll have an image of a person doing push-ups to make sure that they know it's for doing push-ups. So again, we have the source, which is going to come inside here, and the file name is going to be images / pushup.png. So this is what the image looks like, pushup.png, and the alt is going to be, or the text is going to be just pushup guy, and I want a height around, let's say 200 px. That should be good. Now that we have this, let's just write some content on about our page. So what can we write as a content? So welcome to your push-ups logger. Then let's give it a line break. And what can we write here? This website implements basic CRUD functionality and user authentication features using Flask. Simple welcome. And let's see if this has already changed. And yeah, so we just welcome to the push-ups logger. We have the image ready and we have a simple description. So this was it for this video. It is a lot to take in, so make sure you go through the code and make sure that you are good with your HTML, CSS, and JavaScript basics to understand, because I did not write the HTML code from scratch. We talked about URL for and how we can use that to create dynamic links. We talked about template inheritance and how we can use the block control statements with these special ways to actually use Python in our HTML code. And we use that to build our navbar and also the front page of our website. In the previous videos, we talked about how we can set up a Hello World function, Hello World app using Flask. We also talked about how we can use templates and template inheritance in Flask. And using template inheritance, we were able to build a navbar, the code for which is common for all the web pages, but it only has one basic.html. In this video, we'll talk about how users can input their data into a form, and we will be using that concept to build a sign up and login page. So let's go and just make sure our web app is up and running. So we use Flask run, and let's just see that our website is up and running. Yes, and it is. So we'll get to the sign up and login part later, but our website is up and running, and this is how it looked like. And now before we jump on to building the sign up and login page, we have to talk about something called as HTTP requests. And the two very famous and very common HTTP requests are get and post. So the get method is when the user wants to fetch something from the web server, some information from the web server. So when we refresh the web page, we see that the web app has performed a get request where it gets all the code from the server and displays us the code through the web browser. And post is when the user sends some information to the web server. So when a user wants to sign up or log in, it sends its information to the web server, which is then stored into a database, which we'll talk about in a future video. But the main function of a post request is that the user can send information to the server. So using these two HTTP requests, we are going to build up the next part of our tutorial, which is how to build a sign up and login page. So we will not be adding the entire user authentication features today. We'll only talk about how we can send information from the user back to the server and then see how that happens. And we'll also set up some UI for that code so that we can make sure that the project is also up and running as we learn the concepts. So let's get started. Now to build a sign up or login form, we need a form in our website. So as I did for the nav bar, I'm going to go to Bootstrap again and take up the first form here, which is what we need. And we'll be using these forms in our sign up and login pages and use them for later use as well. So these are the forms. The link is in the description, and the code for this video is also in the description, the GitHub repository. Please, you can fork the repo and clone the repo on GitHub and use it as you feel like. So now I have copied this code and I have pasted this in our templates for sign up. Let's see sign up first. We have talked about how template inheritance works in the previous video and how we can also override it with our content. Now here is our code for sign up and login. So for sign up, this is the Bootstrap classes. We have a name, we have an email address, password, and sign up. You can also add another functionality where the user can type the password again to confirm the password and then sign up. And after this, the information of the user is sent back to the server, which we'll be focusing on today. So this is how the HTML looks like. We'll talk about the form methods in a minute, but let's actually see how this works. So we have the HTML file, and now we need a way to actually extract that information from the HTML pages, from the HTML file, when a user actually clicks on the sign up button. So let's see how we can do that. And the mechanism for the sign up.html is under auth, as you remember here. Now, by default, this uses the GET request, as you can see here. And now, when a user wants to send some information to the web server, we have a POST request. Now, in many tutorials, you see that the developer, the programmer, handles both the GET and the POST request in one single function. But just to make the functions really clear and concise, we'll be having another function which is called a sign up post, and only that function will handle all the sign up part uh, regarding the post request. So let's just see how it looks like. So we'll have a route again. So it's going to be sign up because we'll be using that, because the user sends that information back to the sign up route. And now, since this is going to be a post request, we can add a HTTP method here. So methods equal to post. You can also add get, but that is by default, so we'll just be showing post for now. So we have our sign up route ready, and now let's have a sign up post function. Now we have a sign up post. Now we need a few libraries to build this post function. So first we need something called as request, and we need something called redirect. We'll talk about what these mean in a bit. Now let's see how the mechanism works. So we have a form HTML tag here. So the form tag handles all the information that is being sent back to the web server. The method is post, as we're going to send a post request. The action or the route which has to open up, or to which the information has to be sent back, is the sign up route. So here we have our inputs. So the input for name, and we make sure that the ID and the name is also given inside the input, because we'll be accessing the content of that input using the name tags. So give it an ID, give it a name. All of this is from the Bootstrap class here. As you can see, label, input type, class, placeholder, ID, etc. Just add another name here for each and every input tag. So we have the name, we have the email address with the name email, the password with the name password, and when you give the type as password, it hides the text in the password format. Now, when the user clicks on sign up, which is the type submit, what happens behind the scene is that all the information is sent back to the sign up route, and it's a post request. So all the information comes back to this function, and now we need a way to access access those data, right? So first, let's access the email. We use the request library, which has the form function, and we get the email. Similarly, we get two other things. We get the name of the user, which is inside the name, and also the password. Now, in this way, we have collected the email, name, and password from signup.html page, and we can do whatever with it for now. In the future videos, we're going to take up these names and then put them inside a database in SQLite. But for now, I'm just going to display just to make sure that the post request is working. I'm going to display that in the terminal and see whether we're able to get this or not. And also, when we set up user authentication, we're going to hash the password and then store the hash, not the actual password, so that there are no security breaches in our web application. So now that we have this, let's just print them out in the terminal. So we have the email, name, and password. And let's just assume that this has been sent to the database. So now that it has been sent to the database, we have to redirect the user, or direct the user to the login page, because they have signed up now and they can log in. So we use the redirect function. So the redirect function is where you can directly send the user to any page you want. So we use the redirect function. Inside that we have a URL for, because we want to make sure that we're following the notion, to or.login. Now, using the request library, we get the email name and password which has been sent back to this function sign up post. It handles the post request, and once the post has been sent back to this function, we redirect to the login page, because once the user has signed up, they can log in now. So we'll set up the login page similarly in a bit, but let's see whether this works or not. So we can refresh this. We can go to the sign up page and see how our sign up page looks like. So we have the sign up, name, address. You can add another field for confirming the password and sign up. And once you click on sign up, it goes to the sign up post function here, where it has the method post and has the route sign up. We get the email name, password, and then we print the password in the terminal here, not on the web page, because we're going to do that later in the videos. And then we redirect our user to the login page. So let's close our application, run it again to make sure that we can do it now. Let's refresh. Everything is stable. And let's say we have a John Doe who wants to sign up. So John Doe at gmail.com, and the password also John Doe, and sign up. Now, as you can see, when we clicked on sign up, we went back to the login page, and when you see here, we are able to see our email, name, and password. So in this way, you can actually send user data from a form, from an HTML form here, to our Flask function, send it back to the server, and then we can do whatever we want with those information. So for our use case, we're going to store them into a database, and while we do that, we also hash the password so that there are no security breaches. Now similarly, let's make the login page. So again, I use the forms code for my login.html page, which you can see here: login, email address, password, and remember me. So we'll see how we can set this up later. And again, we have the name as email, the password as password, and for remember me, we have the remember ID. So now that we have this, let's just go to name remember as well while we're at it. And now let's see how we can write the code. So the code is going to be exactly similar. We have a login post. Before that, we set our route. So auth.route goes to login again, and the methods is post. And now once a user logs in, we want to redirect them back to the account page, not the home page, because I want the user to see its name in the account, which I will set up in the next video. But so what we do is we redirect the URL, and we do that to main.profile, if I'm right. So let's just see our main, and we have the profile. Yes. So we send it back to the profile, and now here what we do is we take the email from request.form.get, and we get our password. Sorry about that. And let's go back to this. Yes, that was the issue. And let's print our email and password as well to make sure that we have actually got them back on the server using the post request. So now again, the same format. We have the login action, the method is post. We use a form. The form has the ID and name as email, the password as well, and for the input type. Now when we click on login, we also type submit. It goes back to the login action, but a post. So it goes to this function, and we extract the email and password using the request library. We print those email and password, and then we redirect the user back to the profile page. So let's see how this works. We close the port, run it again. Now let's go back. Sign up page is looking good. Login also looks good. So we have John Doe, or let's take Ronak, my name, and sorry, the email has to be ronak@gmail.com. That's not my actual email, but we have a password Ronak123. We press login, and as you can see, we went back to the profile page, and here my email ID and password, which is not my actual password and ID, they have been shown here on the terminal. So clearly this works, and now we can use this whenever we want to build up our actual sign up and login page. So again, to just reiterate on what we have done here, let's go to the sign up page again and see what just happened. We use the form to actually input some data from the user here. Then that data using had sent back to the sign up page, sign up route in a post format. And here in the post function, we get that email and everything back from the user. We print them or we store them in a database in the next video. And then we redirect the user back to the login page because they have signed up now. Coming to the login feature, we go to the login HTML page, we click on submit, we go to the login route with the method post, which is right here. And again, we take the email and password, and here in the next video we're going to check the email if it exists in the database, and if it does, then we're going to log in the user. So we'll be adding those functionalities later, but again, we're able to actually get the information from the user using a form. This is how we can have users input their data into a form and then send the information back to the server using an HTTP post request. So in the next video, we'll talk about how we can show our data or pass our data or Python code from our from our functions, from our Python code to HTML code. So now when a user logs in with the email and password, we're going to show his email ID here on the account page that this is the person who has just logged in. In this video, we'll talk about how we can set up our database in Flask and how we can connect our web application, which we have written in Flask, to the database. For the database selection, we're going to be using SQLite 3. The links are in the description for the source code of this video and the previous videos, and also for how to learn or way to learn about SQLite 3 more. I'm really sorry about the audio quality of the videos. I'm in the process of getting a new mic, and the audio will be much more clearer from the next video. Until then, I'll try to be as slow as possible and also as articulate as possible. So let's get started. So let's see where we had stopped in the previous video. So let's run our web application and let's see how it looks like. So we had developed the front page, we have a navbar ready, we had developed the sign up page and how we can send a post request or how we can send user data to the server and sign up and login. Now we're going to sign up a user or just enter his details into the database, and we'll see how that works. So this is how our init page looks like. So let's add our code to actually initialize our database. So first you need SQL Alchemy in your program, so install that. I'll have the link in the description how to install SQL Alchemy in your project. Then let's import that. So from Flask SQL Alchemy, we import SQL Alchemy. Let's initialize our database. So db equal to SQL Alchemy. We have our instance of SQL Alchemy ready here. Now we need to add some configurations into our app. So first we need a secret key. So usually we have a secret key in a different configuration file, but since it's just a hobby project, we can have a secret key here, which is exposed in the code. And we have another config, which is for the URL of our database. So we will be generating a database. So we need to let Flask know where our database URL is. So it's called as URI. And it starts like this. So it is an SQLite database. So SQLite colon 3 slashes, and it is going to be inside the same structure. So it's going to be inside PL video file for my project. So, and the name will be db.sqlite. This is where our SQL database will be formed, and we'll see how we will be seeing that in a minute. And let's initialize our app in the database. So this is some configuration code which we need when we write our set up our database. And once this is done, next is to create our table. So we'll have a user table for a user to sign up into the website and store his credentials. And all the tables which are created using Flask go inside a file called as models.py. Models.py. I'm sorry about the click noise because that is my new keyboard. I like a mechanical keyboard, so the clicks sound is really irritating for some people. So I'm really sorry about that. Now let's see how we are going to write our models.py. So first let's import our DB. So we had initialized a database here, the DB instance here. So now we can use it everywhere inside our applications with this. So then let's set up a class. We want a user which is going to inherit from db.model. Now this user will have an email ID, a password, and a name. And since each user is going to be unique, we're going to give it an ID as well, which is going to be our primary key. So let's start with the ID. So ID is db.column, and the ID is going to be an integer, and the primary key parameter is going to be true. Next, we need an email. So let's copy this so that we don't have to worry about the rest. The email is going to be a string, and usually emails are around 100 to 200 characters long. So let's give it 100 so that we know that it's not a really big email ID, and it has to be unique. So make sure that it is unique. It needs a password. So we'll not be storing the raw password inside our database. We'll see how we're going to hash our password and store the hash only. And in the next video, we'll actually see how we can rehash or get the hash password from the database, check it with the user entered password in the login section, and how we can log in a user. So everything about Flask login system will be in the next video. In this video, we'll talk about how a user can actually connect the web application with the database. So again, a password will be a maximum of 100 characters. It can be same for different people, so we are going to put a unique parameter there. And the next is name. So we can just copy this actually. You don't need to write it again. The name is going to be a string. So this is our user model for our database, and this is ready. Once we have this ready, all we need to do is initialize or create the database. So now we create the database on the command line. So let's see how that works. Go to your command line, close the server for now, and here open Python, and from your project, so for me it's PL video 5, import the DB instance and create app. So we have our create app here and the DB here from init.py. So let's import that. Awesome. And now let's create all the tables which we have inside our models. So app equal to create app. That looks about good. So now what we're doing here is that we are manually creating all the tables, and we'll have a db.sql file here once we create this. And once that is done, we can start querying or inserting data into our tables. And as you can see, ignore the warnings, and we have a db.sqlite table ready. Close this, and now we can go ahead and add our users inside our database. So now go to our authentication file. This is where we handle everything regarding the sign up and login pages. And sign up post, as we discussed, is what happens when a user sends a post request. So we handle everything here. And let's see how we can input this into our database. So first we need some things. We need to generate a password hash. So let's import those functions for now. So we have this. We need the user table because we are going to add our user data into the user table. So from models we import the user, and as usual we need our database. We have our DB ready. So now we have all the required libraries, and let's set up our sign up page for now. So let's comment this out. And now first, once the user has put his email ID, name and password, we need to check whether the user is actually already signed up or not. So for that, let's extract the user from the database using the email. We have user dot query. We use the filter by function. So filter by the table with the email. The email is the email here, which we have at the top, and get the first result. Now here, what we're doing is we're querying the database or querying the user table to get the row which has the email, and we get the first row, not multiple rows, just to be sure that we get the first one. And once this is done, if the user exists, then we just print that the user already exists, so that people know that they cannot access it. And once we complete this page in the next video, we're going to redirect the user back to the sign up page. So let me just finish this. I think there's some error here. Let's see what the error is. The indentation doesn't match. That's fine. The indentation doesn't match here as well. Okay. So let's clear it now. We have an expected token, which is this. Yeah, we're good to go. So now if user exists, we print and user already exists. Now if the user does not exist, we create a new user. So new user, and we add this. We generate an instance of the user table. So the email is equal to email, the name is equal to name, and now the password is going to be a hashed password. So we're going to use the generate hash function, and let's see what we have the parameters here. So first we need the password to be hashed, and the method we're going to use is the SHA256 method. So SHA256. I'll also link down in the description about what is SHA256. You can read more about it. So now we have our new user ready, and this new user is an instance or an object of the user table. And all we need to do is add the new user to the database. So we have the db.session, and we add a new user. And once we add it, we need to commit and make sure that the user has been added. So yeah, let's check or let's see what we have done here. So in the sign up post, once the user signs up, we extract the email, name, password in the previous video as we saw. We check if the user already exists or not. If it does, we print that it exists, and in the next video we're going to redirect the user back to the sign up page because they can sign up again. If the user has not signed up or the user does not exist, We create a new user object. We add the object to the database and we commit and make sure that the user is there. So let's just check all our files and let's run it and see what we get. So Flask run. So SQL Alchemy has no attribute model. Let's see where we have missed it. Where was the error? The error was in UV. Oh, sorry, it has to be capital. My bad. Now let's go and we're good to go. Let's refresh our page and go to sign up. So we can add my name again, so Ronak. The email ID is ronak@gmail.com. This is not the true and ready, and ronak123. We sign up and let's see what the error is. Okay, so this is where we had an error. So since this threw an error here, the tables inside this were not created properly. So not a problem. We just have to do this again. So go to Python 3 and delete our database again. Move to bin, and now from PL video file we import db and create app, and db.create all, and the app is the app. Awesome. So now the database is created, everything else is done. Now hopefully our should not throw any other errors. Let's see if that is the case. We go to our home, go to sign up, enter the name again, Ronak, gmail.com, and Ronak13. Let's sign up. And yes, we have been signed up and we have been redirected back to the login page. Now, to actually see whether we have signed up or not, I'll be using something called as a DB browser. So I'll link down a link for this as well. So DB browser lets you see your tables, visualize it properly, and see whether all your data is inside your database or not. So we are going to open our database. So let's see. We go to projects. We have our YouTube Flogger, video 5, and we have the DB here. So now let's browse data, and as you can see, we have our name, we have our email ID, and we have the SHA256 hashed password and not the real password. So this is how we can connect our database to our Flask web application. So just to reiterate or go back to the process, we configure and initialize our DB inside the init.py. We make a models.py file with a user inheriting from the main DB model. We have all our columns, the ID being the primary key, email, password, and name. Once we make this, we go back to our terminal, we create the app. So here we have done that. And once we create the app, we can go to auth and check whether the user is already there or not. If it's there, the user is already existing. If it's not, we create a new user, add the user to the database and commit. So this is how we can connect our database to our Flask application. In the previous video, we talked about how we can connect our database with our web application using Flask SQL Alchemy. And we also set up a sign up feature where user can sign up and the data is stored in the database. We also hash the password, and in this video, we'll talk about how we can set up the login function in our web application and also see how we can manage user sessions using Flask-Login. So let's see where we had stopped in the previous video. So let's run our code first. So this is where we were. We had written the backend for the sign up page where the user can sign up and the data is sent back to the database. And we also saw the proof of that data being inserted into the database using the DB browser. The link will be in the description for the DB browser. I forgot to put that in the previous video. So in this video, we'll talk about Flask-Login. So Flask-Login provides user session management for Flask. It handles the common tasks of logging in, logging out, and remembering your user's sessions over extended period of time. So it will store the user's active ID session. So we'll have a current user which we can use whenever we want. It lets you restrict views to logged in users. So, for example, the profile page or the account page will only be seen by the person whose account is logged in, right? So we can use Flask-Login to do that. We can handle the Remember Me functionality. So we have the Remember Me checkbox here, and also it helps you protect your user sessions from being stolen by key thieves. So it is secure. So let's see how we are going to set this up. So first, we're going to go to our authentication.py file and set up our sign up route properly. So remove all the comments, and here now, if the user already exists during a sign up, we redirect the user back to the sign up page. So first change which we need to make, and next now we can focus completely on our login functionality. So we had stopped here where we just handle a post request, and now we need a remember variable to store true if the user has checked the remember checkbox, or else it's going to be false. Pretty straightforward. Now we need to check whether the user exists, and we also need to check whether the password here is the same as the password in the database. So first, let's get the user. So same query here as well. And now, if the user does not exist, or check password hash. So let's import this function first. So let's go up and check password has been imported. And now we check the user.password and the password which we just got from the user. So if this is false, so if the user already does not exist, or if the password returns false, then we return the user back. So, okay, we return the user back to the login page. Login. And now we're good to go. And if the user exists and the password is true, we send them back to the profile page. So make sure that, as you can see, we just have set up the login functionality. We haven't actually logged in or created a session using Flask-Login until now. We'll do that in a bit. Now let's start doing that. So first we go to models.py and we add our user mixin function. So the user mixin function by Flask-Login will add the Flask-Login attributes to the model so that Flask-Login will be able to work with it. So let's see how that works. So from Flask underscore login, we import user mixin, and let's add that inherit here. So we're good to go. Now that this is done, we need to specify our user loader. So a user loader tells Flask-Login how to find a specific user from the ID that is stored in their session cookie. We can add this in our create app function along with the init code for Flask-Login. So here, let's import the login manager. So from Flask-Login, we import the login manager, and let's add the code to that. So simple, pretty simple, straightforward code. So here we have initialized our login manager object. The view is auth.login. So auth.login is where it needs to find the login code /login here, and we init the app, a simple boilerplate code. And now we need to have a user loader which tells Flask-Login how to find a specific user from the ID stored in the session cookie. So here, let's get our user model here inside, and now we have a login manager dot user loader, and let's load the user using user ID, and we return user dot query dot user dot query dot get int user ID. So now Flask-Login knows how to find a specific user using the session cookie, this piece of code. And now let's set up our login session inside our login post. So we need a few functions. So let's get those functions here. So from Flask-Login import login user, log out user, and login required. So here with login post, we're going to log the user in. So login user, which is the user, and remember is what we have passed. So let me spell that right. And yeah, now we have officially logged in the user. And the next is logout. So logout is pretty straightforward. First, we have a decorator which says login required. So you need to be logged in to access the logout page. And then we can redirect the user back to the home page, so main.index. And now we just need to say logout user. And we have logged out the user. That's pretty straightforward, pretty direct. Now that we have a user that is logged in, and now when the user logs in, it is sent back to the profile page. So the profile page also has to be protected, and it should be login required. So let's first add that. So from Flask login import login required, and we need the current user here because we're going to print the current user name in the profile page. So we have the login required current, so login required, and inside our profile.html, let's send the name as current user dot name. Now that we have sent the username, let's see how we can handle it here. So we have the content block, and inside this, let's have an h1 tag. Welcome name using interpreting, and that's it. So now when the user logs in, goes back to the profile page. In the profile page, we have a login required decorator which ensures that the user is logged in, and it shows the name of the user or the person who has logged in. So that's nice. Now we need to make some very small changes in our base so that we can set it up better. So let me just tell you what kind of changes. So we have a form here where you can log in and log out. So let's convert that form to something else. So now if the user is logged in, he can add a new workout. So we'll be adding functionality for this in the next video. If the user is not logged in, then show the sign up and login buttons. If he is logged in, then show the logout button. Pretty straightforward, pretty simple. Just make sure it is there in the base.html function. And yeah, now as this is done, let's just check if we have done everything correctly. So we have set up the login manager here. Make sure that the user can log in and we can get the current user from here. Now, next thing is models. The user mixin is ready so that Flask-Login can get the user attributes. Next is the login function where we have logged in the user. We can log out the user, and in the main, we can check the profile page. So let's see how this works. We have switched on our server. We have sign up page. So we'll sign up for something else. So test 123 or test123 at gmail.com and test123. Let's sign up. Let's log in to test123 at gmail.com and test123. There's an error. Let's see what the error is. Remember is not defined. So just a second. We go to auth. So yeah, let's run it again. We are already signed up, so all we have to do is log in now. So let's go to home. Let's go to login. Test123 at gmail.com and test123. Let's log in. And as you can see, we are in the profile page. So and we have our two new buttons. So we have logout and add new workout. So now when you go to account, you can see that it is currently saying test123. And we'll be working with these two buttons in the next video, but we have almost finished our web application. And now when I click on logout, let's see what the problem is here. There's some errors, so yeah, we'll fix this in the next video. There's some pretty simple errors, nothing else. Main.index, we log out. So yeah, we'll see this in the next video, but for now, yeah, this is how we log in a user and handle the user sessions. Thank you. So before we start today's video, I'd just like to say that a lot of people have been asking me about learning Python, how to learn Python, and how to go about applying jobs. So I usually take 2 to 3 video sessions, one-on-one sessions, where I talk about how to learn Python, to schedule classes with me, about resume writing, about how to prepare for internships and placements. So if you want to have a conversation with me on a video call, then we can surely set that up. All the information about contacting me is in the links in the description. So yeah, now that we have got that aside, in the previous video, we talked about how we can add Flask-Login to our web application to handle user authentication. We were able to set up some pages which can be only accessed if you were logged in, and how that session management takes place. We also talked about how you can access the current user that is logged in and handle those attributes. And we also played around with how to have some pages, so for example a profile, to display the current user's name in the profile page. So in this video we'll talk about how we can create the main feature of our web application, which is the CRUD, the create, update, delete features. In this video we'll talk about how to create workouts and how to show them or display them, and in the next video we'll talk about how to update and delete them. So let's get started. Let's check if our Flask application is up and running since the last video. So yes, it's running perfectly well. Let me just check a few other details, and it's good. Awesome. Now first, we need to add or have our workouts into the database, because we have to show them and we have to maintain or keep track of the workouts for each user. So oops, let me just get rid of this for now. Yeah. So we are going to have another table in our database called as workout, where we store some information regarding the workout, and then let's see how we can access that or add some information into that workout or create a workout and display them on the page as well. So first, let's get started. So we need a class of workout. Simple stuff, nothing new here. We need an ID. What's next? We need, this is a push-ups logger. So we need to keep a log of how many push-ups somebody has done. So we need push-ups equal to db column, and this is going to be an integer as well. Let me just copy a bit. Not going to be a primary key, but it's going to be something else. So null AB. So this cannot be 0. So you have to log at least one push-up. I think you can definitely do one push-up. So yeah. Next, we want to keep track of when the push-ups were done. So date posted. It's going to be db column, and this is going to be db.date time format. Again, cannot be null because it's going to be input automatically using default. It's going to be something here. So we need from date time import date time. Yeah. And here we're going to have date time dot UTC now. So I'll be storing the date in UTC format, and you can change that to IST or any other country or time zone you like. Awesome. Now we need a comment. So how was the workout? Was it easy? Was it tough? So you write that here. So again, column, but this is going to be text. And again, at least put in something inside that, right? It's good to have a journal where you can track your push-ups and also see the comments, because then you see how you're being better as you do it. And next, we want to link our workouts to the user. So we'll have the foreign key. We'll use a simple foreign key which is connected to the user ID. So user ID is equal to, sorry about that, db dot column db dot integer. Now it's foreign key, and it's going to be from user table and the ID column. Again, cannot be null. Awesome. So now we have our workout table ready. Now we just want to have or find a way to link our user or keep track of all the workouts under a user. So let's see how we can do that. So workouts equal to, we have to make a relationship. So relationship, and it's going to be with workout. And how are we going to have the relationship? So we'll use something called as the author of the workout, and lazy is equal to true. So just make it easy for us. Now we'll see what this means. So what we just did here, we'll see when we implement the add workout function. So now our table is ready, our database is ready for workouts to be added. Now let's set up the UI and the APIs for that. So first we need a way to add a new workout, right? So main, let's create a route for that, /new, and you have to be logged in to see that view. So new workout, and let's just render a template here. So create workout.html. So this is just going to be a get where you can just see the page to create a new workout. We'll be having another function to handle the post request. So just copy all of this here. This is going to handle the post method, and this is going to be new workout post. Instead of rendering this, we want to render this to the main, render it back to the main page, because you've added the workout and you want to see it. So this is done. Now we need to add some logic here on the post request, but let's create the HTML page for create workout. So new file, create workout.html, and since I don't want to focus on the code for the workout, let me just paste it and go through this. So first, the same old blocks, inheritance, and then we have some new things here. So we just want to display some flash messages. We'll talk about this later, but bear with this for now. We'll have a complete video only on this because they're really important. Then we have a form, so post to new, where this fellow function comes into the picture, and we have the push-ups, a comment, and you're able to add the workout. Now, awesome. Now let's see what do we do with the information. So first we do push-ups, go to request.form.get, nothing different, just the same stuff here. We do the same for comment. Now we need to add this into our database. So workout equal to workout, we need to use the workout class, but we haven't imported that yet. So let me just import everything now because we are almost at the end. So we need the database, we need the user, workout, and all the other things. So workout, and now let's add our stuff. So push ups equal to push ups, comment equal to comment, and author, which we talked about, is going to be the current user. So the author here, which we talked about, the way we link or form a relationship between the user and the workout is through here. So now Flask understands that this workout belongs to this particular user that is logged in. And now simple stuff, we are just going to add it to this DB session and commit, and then we redirect back to the main. Now let me just flash a message here, which we'll talk about later. I'm sorry that the workout has been added. And yeah, so now we will be able to add a new workout. Now, before we test that, let's see how we can display our workouts as well. So next, let's have a function or a route called as all, where we can see all the workouts, and obviously it's going to be login protected, and we'll call this user workouts. Instead of actually redirecting to the index page, let's actually return this back to user workouts so that the user can see all the workouts. And here first we need the user, right? So user is equal to user dot query dot filter by, and we'll be filtering by email, so the current user dot email, and get the first thing we get. First, but let's use first our 404. So Flask automatically shows a 404 page if the user is not in the database. And let's extract all the workouts now. So it's going to be user dot workouts. So this we're able to do because of this and this. So now that we're able to form a relationship between the user and the workout, we can directly access this. Awesome. And now let's return render template. We'll have an all workouts page made right now, where workouts equal to workouts and user equal to user to pass the information. Awesome. Now let's head here and do all workouts.html, and again copy the code. So we first welcome the user. We have a table. So we have a table where we show the number of push-ups performed at, so the date and the comments. So now we access them by workout.pushups, workout.date posted with a handy way to display it and comment. Next we have the edit and the delete button. So let's make them hash for now and not worry about them now. We'll see this in the next video. But yeah, so what is happening here? What did we all do? So first we have a new page which just shows the new form page for creating a workout. Then when the user sends a post request, we get the push up and the comment. We create a workout object, add that to our database, commit, flash a message that has been added, and return the user back to see all the workouts. And how do we show the workouts now? So we have an all page where we get the user, by the current user is logged in by the email. We get all the workouts, and then simply we just display or show all the workouts in Ginger templating. Now, let's just confirm that whatever we have done is looking good so that we can see and run it to make sure that there are no mistakes. And by the way, oh yeah, so in the previous video, we had some trouble with the logout function. We had some errors, so this is how to fix it. Somebody in the comments of the previous video also had the same solution, so thank you for that. And yeah, let's run this and see how we have done, if we got this right. So yeah, we haven't, where we cannot spell, so I cannot spell apparently. So where was that? Yep, right here. Awesome. Let's try that again, and looks like we're good to go. Let's refresh our page. Let's sign up again. So test test234@gmail.com, and the password is test234. Sign up. Sorry about that. Let's log in. Test234@gmail.com, and the password is test234. And we have logged in. Awesome. Now let's go to add new workout. Oh wow, we didn't change that. My bad. So we go to base. This is where we have our base. And so yeah, I knew we were missing something. So we go to this little guy here to add new workout. Instead of profile, what do we need? We need new workout, right? So let's go to base and add that here. My bad. I think we're good to go. So we can just close and open this again. Awesome. So we are still logged in. So we are still logged inside test. Let's go to add workout. I actually did do 20 push-ups today, if you believe it or not. And it was kind of fun. Add workout. And we have an error. So what is the error? No sustainable workout. Okay, so we made some error here. So workout, there is no table as workout. So let's see what the mistake is here. Everything looks good. We haven't done anything yet. So why does it say no workout table? So let's see if the table was actually created. So we have the DB browser for that. And yeah, so open database. Let's go to projects, go to push-ups logger, and we got it right here. So yeah, we have just one table. So yeah, we had not created the table. Let's see why that happened. So what we can do here is this. So usually when this happens, I create the tables again. So let's see how we can do that. So again, clear this out, use Python 3, and give me a minute until I get that. So we're going to create all the tables again and see how that works. So we configure the database, and yeah, right here. So we need create app and DB. So from I keep forgetting the name. We import DB and create app, and yep, we did that. And let's read the database first, just to be careful. Close this and Yep, we're good to go. So sorry about that. We have to do this again. And yeah, let's run this back. Flask run. Let's see everything from scratch and make sure we have our database ready. So DB browser, we created the workout table as well. Let's open the database, projects, pk logger, and yeah, we have the workout table. Awesome. Now we can continue the same work. We sign up with test234 at gmail.com and test234. Sign up. Ignore. And let's log in. Test234 at gmail.com and test234. Login. Awesome. Now let's add a workout. So again, the 20. It was kind of fun. Add workout. And here you go. So sorry about the HTML. I'm really bad at UI, but now you can go to all workouts and oh my bad /all, and you can see the workout. So let's add another one. So I did 20 again. So this is a lie. Add workout, and here you go. We were able to add the workouts. We could see when they were performed, and in the next video when we do update and delete, we're going to definitely fix the HTML as well. In the previous video, we talked about CRUD operations or create, update, delete operations. And we started that by creating a workout or how to create and display all the workouts. In this video, we'll talk about the other two operations, which is update and delete, how to update a particular workout or delete the workout. So these three operations, create, update, delete, form the basis of Web 2.0, where a user can interact with the website to change operations or delete content on the website. So let's get started. Let's just see where we had left in the previous video. So we were here where we were logged in with test, if I'm right. Yeah, we had all the workouts. Let's add another one. So I didn't do any push-ups today, but let's just say that I did 10. I'll do 10 later, and I'll just do this later. So this is not how it should be, but well, yeah. And this got added. You can again change or sort by dates in the database, etc., etc. That's up to you. In this video, talk about edit and delete functionalities here. So we have the buttons, but they have nothing, as you can see here. And let's get into it. So first, let's close our server. And now we go to the main .py page where we had all our features ready. And now let's make the update function. So now we have to update our workouts, right? So we have to update each of our workouts. So we need a way to access each workout uniquely, or a way to have a unique ID for each workout. So that is what we did in our DB, in our models.py, where each workout has a very primary key or a unique ID. So this is how we're going to access our workouts and then update them. So let's see how we do that. So first have a main dot route, and I'm going to fill this later. For now, actually, we'll talk about what's going to happen here. This is going to be a login required function because we need to be logged in for that, and update workout. And there's going to be something here as well, but yeah. So now what is going to happen here? So first, we want to access each workout, and the URL for that should be generated automatically by the workout ID. So if I want to update the first workout, so it should be workout/1/update. If I want to update the workout number 100 or the ID 100, it should be workout/100/update. So we want to have that URL be generated automatically. So this is how we can do it in Flask. So we have workout. Now the workout ID is an integer. So this is the syntax. So int, we have a colon, and what is the variable name going to be? So let's say workout ID. And how do we get this? So we'll talk about this later. And slash update. And now the methods are going to be get and post. So usually I used to make two different functions, right, for get and post, but today we're going to do both them in the same one to see how it works, because we haven't done that yet. So now this workout ID, how does the URL get it? So it gets it from the function parameter, so workout ID, and this is how this is passed to this using Flask. And now first thing, we need to get our workout, right? We need to get our workout, which we have. So workout equal to workout dot query dot get or 404. So now we access this workout using the workout ID. So we have the workout ID here in the parameter. So now once we have the workout, we send this to the get request of the template. So let's see how we do this. So we just do return and render template. And we're going to make a page update workout.html. So update workout.html and pass in our parameter, which is workout equal to workout. Now here we have just shown you the workout ID and update workout page. We haven't received any updating information. So which is going to be the post request, where the user sends in the information which we want. So if request dot method is equal to post. So if the user has passed in some information, we need to get them back. So we're going to write that logic a bit later, but first focus on the update workout.html page. So let's go there. Templates. Let's make a new file. Update workout.html, and let me just get the code for that right now. And we're good to go. So here again, simple, straightforward code for HTML. We have our block content. We have the flash messages we'll talk about in a different video, so just bear with me there. We have a form. So we have to talk about this now. So we'll talk about this in a minute. A simple form with you can update your push-ups and comment, and it says update workout. So here, what we're doing is when we make a post request, we want the user to go back to update workout. We want the user to go back to update workout, but also pass in the workout.id. So we have the workout which we got it from here, and we want to pass the workout ID to the post, so inside here. So once we pass the workout ID, we can then extract the workout and make the changes in the database. So now, once the user clicks on submit, you go to update workout post, send workout ID here, and now let's see how this works. So now, all we have to do here is workout dot pushups is equal to request dot form pushups. So let's take the pushups which you updated, and the same for the comment. And yeah, now we have this. We have our workouts here, so we have added that to our workout object, and all we have to do is db.session.commit, and the workout has been updated. And let's just give through a flash message. So I'll talk about this in the next video for sure. So your workout has been updated, and now we want to send the user back to our all workout list, right? So let's do that right now. We return the user back to user workouts, which is here /all. So what did we just do? So we were able to extract the workout, go to update workout.html using the workout ID for that specific workout. And once we do that, we go to update workout, we fill in the information, then we send a post request with the workout ID for that specific workout object. And we take the push-ups and comments and save them inside their own attributes and commit, and the workout has been updated. So let's see this in working. Hopefully we haven't done anything different which should throw an error. Oh yeah, we have to update the base. My bad, my bad. So give me a second. Let's find our base for update workout. So add new workout. Everything is good here. Nothing such. So we just have update workout, right? Oh, my bad. So it's in all workouts. Yeah, edit. So we go to all workouts, and now we need the URL for edit. So again, the URL is going to be what we have made. So update workout ID is going to be workout.id. So get the current workout ID and throw that for the URL. And yeah, we're going to talk about delete in a bit, but let's see workout updation for now. Yep, all good. Go to all workouts, and now as you can see down in the bottom left, it's pretty small, but you can see by the ID edit workout 1, 2 and 3. So let's see the one which alive. So you go to edit, workout has been added, so just forget the flash. And now we have to update the workout. So 12, and this is a true statement now. And we click on update workout, and here you go. The update, so workout has been updated. We can do it for this similarly. So okay, I think I made a mistake somewhere here. This should not be showing it here, but we'll fix that later. Flash is just another video, as I said. Again, so let's do 100 and too much. Update workout, and here you go. So we were able to update our workouts directly, and now we need to focus on deleting workouts. So this is going to be pretty straightforward, nothing complicated, no HTML pages. All we have to do is delete the workout. So let's see how that works. Again, uh, each of it is going to be, each workout has to have its own ID to be deleted. So workout slash delete get and post. We just have a get, we don't need post, but I just copy pasted it. So def delete workout. Again, you need a workout ID, and now get the workout. So we need to get the workout from here by the ID. Got the workout. Now this is a simple db dot session dot delete and workout. So we delete the workout object. db dot session dot comment. We always comment our changes, and we're good to go. We have deleted our workout, and all we have to do is redirect the user again to all the workouts. So same thing, we get the user by get the workout by the workout ID. We delete it from the database. We commit, and then we return the user back. And let's see this in action. My bad. Yep, we're good to go. Again, we missed the HTML page. My bad. I'm really sorry. We need to go to all workouts. So let's go to all workouts again and fix our hrefs. So give me a second. Let me just get this directly on delete. So yeah. So again, main.delete workout, workout ID to workout ID, and yeah, we're good to go now. So Flask run, and let's see. So all workouts. So let's just delete the one which we have 100 workouts, 100 push-ups, right? So just click on delete, and here you go. It has been deleted. So let's delete another one and another one, and we have no push-ups. So let's do everything from scratch. Okay, so we are logged in. We have seen how that works. Go to account. We have a test user. Add new workout. Sorry about this. I have to change this in the next video. Push-ups. We did 10. First workout. Add workout. And here we go. Edit. Again, let's say 10. First edited workout. update workout, and we have updated it and we delete it. So yeah, so we have built our web app where we can have user authentication using Flask-Login, and also we have created all the CRUD operations. So let's go back to how did we do it. So to create it, a simple post request where we take all the information from the user, create a workout object, add the workout object to our database and commit. Simple, pretty much, nothing complicated, and then we just show all the user workouts. How do we show the workout? So we show it using linear templating, where for all the workouts, let me show it to you right now. So we send workouts and user. So for all workouts, we show the push-ups, date posted, and comment. Going to delete or update, we update the workout by its workout ID. So we get the user workout by the workout ID. Then once we get the information, we change the push up and comment attributes or variables, commit them to the database and show it back. For deleting, we just delete the object which we get by the workout ID and commit. So yeah, pretty straightforward, pretty direct. So in the previous video, we talked about how we can set up our application, how we have also finished the CRUD operations in our web application, the push-ups logger, where you can log push-ups. So today we'll talk about something called as message flashing, which I have been delaying for the last couple of videos. So we'll get done with it today. We'll see what it means, how we can use it, and how it benefits our application. So before that, if you want to learn Python, if you want to understand how to write a good resume or a good cover letter, if you want to know how to prepare for software engineering jobs, for placements or internships, then my contact information is in the description, and we can have a one-on-one call where we can discuss all of this. So yeah, now that we have finished that part, let's see where we were before. So let me start my application. So it was in 5,000. Yep. So this is where we were. We had a login sign up. Let's just test it again. So test. Let me see. Okay, so let's just make another one. So test user testing at gmail.com testing. Yeah, let's sign up. Let's log in. Testing at gmail.com and testing. Let's log in. Cool. So we have logged in and we are in our profile section. So you can add a lot of things here. I haven't. I just wanted to show you how we can add our current user information from the database to the page and how login session management works. But you can add a couple of things. You can add the name, the email. We'll add a forgot password situation later, but for now this is how it is. So this is our application. Let's add a workout to make sure that it's perfectly running. So we have our create operation right here. So 20 push-ups, did 20, gotta do a few more tonight. Add workout, and yeah, so this is what I was talking about. So these flashes which we need to fix, we need to change. So we need to see why this is occurring, what we can do about it, and how we can fix them properly and show the right messages here. So yeah, now that we have it here, let's go to all workouts. Let's go to edit and see if edit is working. So we did 21, did one more update workout, and yep, this is working properly. And delete, post has been deleted. Awesome. So yeah, we want to know what all of this was. So simple text which is shown about what operation has been done, but it is officially called as message flashing. So good applications and user interfaces are all about feedback. If the user does not get enough feedback, they will probably end up hitting the application. So if I add a new workout and I don't get information about did my workout actually get added, I can see the workout that it has been added, but I also need some dialogue, that some feedback that yeah, my workout which I have updated has been added, or it has been updated or deleted. So Flask provides a really simple way to give feedback to a user with the flashing system. So the flashing system basically makes it possible to record a message at the end of a request and access it in the next request and only the next request. This is usually combined with a layout template that does this. We should make sure that some browsers enforce a limit on the cookie size. So if your message is really long for a session, then it will cause the flashing to fail, but silently. So you will not know that the flashing has failed, but it will show up when you are actually deploying your application. Oh yeah, by the way, so we will be deploying our web application on Heroku so that we also finish the deploying part of our application, the DevOps part a little bit. So yeah, that is going to be the next video where we learn how to deploy our application on the internet. So let's see how flashing works. So let's open the documentation. Message flashing. So just let me fix that right now. Yeah. So this is how it looks like. So we have a simple documentation where they explain how they flash you were successfully logged in. So if a user has logged in, then you say you use Flash. So you import Flash and see you were successfully logged in. And in the layout page, we use Ginger templating, and with messages we use the get flash messages from the Flash uh, import. And once you get the messages, if there are any messages, so sometimes you don't flash anything, but you might when you have a post request. So there we can have if messages do this, and for all the messages list them out. And you have the flashes class provided by again Flash. So yeah, this is how it looks like, a simple with statement with if, else, end with, end if, and you're done. So we have used this in our application as well, but since I have been ignoring the HTML part of it for a long time, we'll actually get into this. So first, let's see where do we actually use it. Where do we actually use Flash in our application? So first, we have our new workout post where we update or add a new workout. Not update, but just add a new workout. So we flash that the workout has been added to user workouts. So let's see what our user workouts look like. So user workouts is all about all workout.html, right? So let's go to all workout.html. And as you can see, with messages get flash messages, and if there are any messages, then notification is. So we just skip this. We don't need this class right now. Let's just try this one. So class equal to flashes. Class equal to flashes. Yep, I think we're good to go. Okay, so we don't need that. So flashesh. If I'm right, yep, good to go. So yeah, now we display all the messages and we end with. So we just used this example right here from documentation. We didn't add anything else new here. And now that is how we implemented Flash in our application. And let's see where else we have done that. So we have done that in our update workout. So whenever there is a post for update workout, we show that user that the workout has been updated, and same for delete, where we show that the post has been deleted. So this is how our application works. And if you go here, you go to add new workout, do 23 and videos, add workout. The workout has been added, perfect. Our application shows it perfectly. And we go to edit, we change it to something else, update workout, and the workout has been updated. Same goes for delete. So when you press delete, your post has been deleted, and you can see that everything has been gone and your flash messages are being shown perfectly. So this is how we actually work with message flashing in Flask. A very simple, very common thing which people use for applications, which we need to know. In the previous videos, we talked about how we can build a fully featured CRUD application with user authentication features, where we had a login, logout feature, and also how we can create, update, and delete our workouts. In this video, we'll talk about something called as pagination and how pagination works in Flask. So let's see how our app looks like. So here, as you can see, we are logged in into our test account, and when you go to all workouts, I've took the liberty to add a few placeholder workouts here. So as you can see, there are total 16 workouts, and it becomes tedious to scroll all the way down when we have a lot of workouts in. When you track your push-ups for around 2-3 months, this becomes really tedious to scroll all the way down. So now we are going to add a way to have pages or paginate our application so that we don't have to see so many workouts in the same place. We can have multiple pages where we can see our workouts. So let's see how we can build this. So now let's go to the main file and try to locate our workouts. So here we need to make some changes inside our all route where we show all the workouts. So first, instead of using user.workouts or accessing the workouts in that way, what we can do is use a different way. So what we can do is use workout.query.filter by, and we filter the workouts by the user. So the author is equal to user. Now, it was similar to what we had done before, but the only difference is that we're using the workout class to actually get our workouts, and we're filtering by the user, which is the current user in this case, as you can see on the line on top of it. Now, all we have to do to have pagination in our application is to have a dot paginate function called to it, and that is it. So, of course, there's more to it, but let's see how this works for now. So let's first decide how many workouts do we want in a page. So this has around 16 workouts. So let's see if we have 3 on each page. So let's just say per page equal to 3. And now let's see what this paginate function gives or returns for a workout. So print dir, the way we can print all the methods our workouts object has. So workouts, and let's see what the output is. So let me clear this out, run the application again, and let's refresh this. And there's an error, so give me a second. So it's not iterable. Okay. Oh, I see. So since we have changed our workouts, we will also need a way to change these. So let's do it a bit differently. My bad. So we'll keep this here, and we'll say workouts paginate, and go to workout dot query dot filter by, and we filter by the author, which is the user. We call paginate, and we make sure that there's only 3 per page. And what we can do now is just print all the methods which we have under workouts paginate. So yeah, now we won't break the application, because once we have our paginate method on our object, we need a different way to handle these for loops here. So yeah, this should work now. Let's go back and change our server, and let's refresh. As you can see, it's not breaking, and here we see all the methods that are available with our workouts object. So we have the class, attribute, new, reduce. So for pages, we have has next, has previous, items inside each page, how to iterate or iterate through pages, the next page, which page it is currently in, the per page items, previous, etc., etc. So now we can use these methods to actually have pagination inside our application. So let's see how that works. First, let's just print some uh, method just to make sure it's working. So let's just print items, workout.page items, and print workout.paginame.page. So we want to see the items inside each page and also the page on which we are. So let's run it again, and we can refresh our page. And as you can see, we have only workouts 2, 3, 4, only 3 workouts in our first page, and we are on the first page. So now we know that the paginate method works, and let's see how we can include this or connect this with our front end and make sure this works properly. So now what we need to do is first we can, oh, sorry about that, we can remove this and now replace this with our workouts variable and completely remove this. First, now that we have pagination into our web app, we need to know or we need to tell our application which page to be in, right? So what we can do is whenever we change a page or whenever we go to the next page, we have a different URL which is question mark page equal to something. So these are the parameters in on our URL. So we need a way to actually get these parameters and then use them to change our pages. So here we can use request.args, get the request arguments, and we need the page argument. Uh, by default, so the next parameter is what should be by default. So if there is no page argument, then it's 1, and the type which we accept is int. So here, after the question mark and page equal to, there'll always be an int and nothing else. So now that we have the page, so if we are on page 2, then this gets the 2 value on the variable, and we can pass that here into our paginate method. So page equal to page, actually my bad. Yeah. So what is happening here? So first, we by default are on the first page where we see all the initial workouts, and then we pass and when we go to the next workout and when we press the button for the next workout, we get a different URL. So it's going to be page equal to 2. So this 2 is sent back to the page variable, and it is sent back to the paginate method, and the workouts 4, 5, 6 are then shown on the HTML page. Now that we have we are almost done with the backend, let's see how we can connect this to the front end to show the pages into our web page. So let's make some changes here. So first, I don't think it's good to have everything on this left side. So let's change that first. Let's center everything. So I'll just use a center tag. Won't make it complicated. Just get everything inside this. And let's use this tag again and do this once more. So yeah, so let's just see if that was right and everything is centered now. So we just need a simple all, and okay, my bad. So yeah, since we have made some changes here, we will not be able to render this one properly, but let's talk about the centering later and focus on pagination. So first, now we cannot use for workout and workouts because workouts is now an object. So we need to use workout.items, which is going to be our loop to loop through all the workouts and get the push-ups number, comment, and date posted. And next, we need to make some changes or add a few things inside our file. So let's see what they are. So first, we need to loop through all the pages that we have. So we use Ginger templating here for page num in workouts dot iter pages. We saw this when we were listing all the methods, and let's see what parameters to add. So I'll just add the parameters and then let you know what they do. So left edge equal to 1, right edge equal to 1, left current equal to 1, and right current equal to 1. Okay, so now what did we do here? So when we are iterating through our pages, so when we have those buttons to navigate through different pages, we just want to show one page on the left of the current page, one on the right edge, and one just adjacent to the current page, and one just adjacent to the right. So we don't want to populate our entire pages list with all the pages. Suppose you have 100 pages, you don't want to show 1 to 100 buttons on the bottom, right? So we just show one current page, or one current page, left to the current page, right to the current page, and the rightmost page, so that it's a bit smoother. And now we need to have some conditions. So let's see what they are. So if we are on the page which is currently open, so if workouts dot page is equal to the page now. So if we are on the page where it's supposed to be, right? So we will be having a different button. So I'll just talk about that in a minute. So now if we are on the exact page where you want to be, then it's going to be having a button class, button info. So this is going to be a button filled with blue color and have some spaces, and it's going to link back to user workouts, which is right here, and we're going to pass the page num as page num so that we know which page to go to. And if that is not the case, we're going to have an else. So else, and if we are not if it's not the page number we are on, then don't show the highlighted text but show an outline of it, and we'll see what I mean by this in a bit. And we can end the if. So just before we end the if, I was going to add something else to our page. So we did end the if, so let me just add a few things here. My bad. So if page num, first we're just making sure if there is a page num, if there are pages or not. If there are pages, then check which page we are on. If we are on the current page, then show that button differently, or else show the outline of the button. And when we are only showing left edge, right edge, and one left current and right current, we want to show everything else by a dot dot dot, so that we know that there's something in between them. And yeah, so I think we're good to go. We were able to handle everything properly. So what changes did we make here? So we iterate through all the pages, make sure the parameters are right. If the pages exist, then if we are on the current page, show a different button. If we are not on the current page, then show a different button. And if we have a lot of pages in between, show the dot 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 symbols, so that we know that there is differences here. And yeah, so now we can run our application and see what we've done. Let's refresh this, and as you can see, now we have 1 to 6. So now let's go to a different page. So let's go to page 2. So as you can see, we have the dot dot dots, and we can navigate through 1, 2, 3, 4, 5, 6. So let's go to 3 again, and here we have 3. Let's go to 4 or 5, and as you can see, 2 gets hidden, so it's easy to navigate back and forth. We can add a bit more here, so that it's not just 1 and 6 but a bit more. But as you can see, we go to 6, we get the last workout. We go to 5, we get the workouts before that. 4, the workouts before. 3, and so on. So this is how we add pagination to our web app. And just to reiterate on what we learned today, First, we use the paginate method to do this, and it returns a paginate object. Then we make sure that there are only three per page. So this is up to you. You can decide how to have how many number of workouts you want in a single page. Then just to make sure that we can track different pages, we know that the URL is going to be like this. So page equal to 1. So we get the parameters, and once we get it, we save it in the page and pass that here. And again, we go to our HTML file, and to show this or render this, we loop through all the pages, set our edges, and show the buttons. So as you can see, the page I am on 1, we have the button info class, and if we are not on the current page, then we have the outline class. So now if I go to page 6, then 6 has the button info, and 1 and 5 have the outline class. So this is how we know which page we are on, and the rest are been showing by a dot dot dot. So yeah, this is about pagination, and now our application is completely ready, and we can now deploy our application. Now it is time to deploy our website onto the internet with the database. So we are going to use Heroku to do this. Heroku is a platform where you can host and deploy your web applications, and they give you a very easy way to do it. So we're not going to use the Heroku CLI. I think we can do this in a much more smoother way using just the GUI or the user interface provided by Heroku. All you need to push or deploy your website to the internet or web app to the internet is a GitHub account and an Heroku account. So before we move forward with this video or tutorial, make sure that you have a GitHub account ready and you also have a Heroku account ready. It's completely free to make both of them. And even today, we're going to deploy our website or web app for free. So let's get started. So here I have my folder inside which we have all the files. So let's just change the name first. So this is going to be push-ups logger. Because it contains the push-ups logger app with the init file and everything else. So now let's move into this, and we're going to write some code, not a lot of it, but just a little bit of code to see what do we need to add to this, right? So my bad. We don't need to go here. We need to take it a step back. Yep, and we need to go here. So we need to have some files around our push-ups logger app. So this is our app. Let me just delete this and get it out of the way. This is something which happens on my laptop. Don't worry about it. It's how I back up my files to the drive. So it adds an icon file. So don't worry about that. So we have our push-ups logger app, which works perfectly, and we need to add a few files. So first, we need to have a requirements.txt file, which stores all the pip packages that we have used in our app. So we have used Flask, we have used Flask-Alchemy, Flask-Login, we have used, where was that? Works security, I don't know how to pronounce that, but this dot security. So we have used so many packages, and we need to have requirements.txt so that we can tell Heroku that before you start the application, you need to download these packages and then start the application. So usually, what you do or what people do is they use something called a pip freeze, and that saves all the names of all the packages that you have in that environment. If you have a virtual environment, then all the packages enter the virtual environment into that requirements.txt file. But I usually don't use that for small projects, so I'll show you something better. So this is open source, completely open source. It has an Apache license, so please go through that. And this guy made this project called as piprex, so it generates the txt file for any project based on the imports, which is exactly what we want. And very easy to install. Pip install piprex and you're good to go. And he also talks about why not pip freeze. So pip freeze only saves the packages that are installed with pip installed in your environment. It saves all the packages in the environment, including that the ones that you don't use in your current project. And that is a problem. And sometimes you need to just create this without installing modules, right? So this is exactly what we'll be using. So here we have our pushups logger inside, and we need to have a requirements.txt file on the same level. So all we do is pip rex and a dot, which is that look inside the current folder, and we press enter, and we have made it. So let's just see this here. So we have made a requirements.txt file, perfect. And you just need another thing. So you need something called as Gunicon. So we just need this. It's a web server gateway interface server module which you need when you're hosting websites. So all you have to do is just do pip3 of the pip install Gunicon. You'll have it, and then just add it here just to make sure that it's there. And yeah, now that we have finished our requirements.txt file, we just need another file which is called as a proc file. So let me just write the file. Oh, I misspelled it, my bad. It's proc file. So as you can see, we already has the Heroku symbol right here. So the proc file is how the project knows, or how Heroku knows that what it needs to do with the project. So let me just show you what we have. So web Gunicon app. So I'll just tell you what all of this is about. So first, we tell Heroku that it is a website or web-based project, and please use the Gunicon server. Let me show you what Gunicon is again. Please use the Python web server gateway interface to host our application on the website. And the next is app. So the first app is your file or the folder where your Flask app is. So we haven't made this yet. We don't have an app, a file named app or a folder named app. And the second app here is the Flask app which you have, which is basically this return app. So this Flask app. So how are we going to make this? Let's see how we do that. So we create a new file, app.py, and we'll just add some simple stuff. So just don't mind me here. Just copy these simple things and just paste them here. Yeah, so what did we do here? So from pushups logger, so from our application, we import create app. So create app is inside init.py. So it is going to be there when we always import. And then we say app equal to create app because it returns the app. And if name equal to main, we run our application. So we have a place or a file where we can actually run our applications from, which we need to direct this to Heroku. That's it. So we can use Flask run, and we can use environment variables and export the path, but this is a much easier way to do it. So we have everything ready. We have a requirements.txt file, we have a proc file, we have app.py which runs our application. You can just type python3 app.py and get the server running. Now that you have done, and now that we are ready with all of this, all you need to do is just push all of this to your GitHub repository. So I already have one here. The link is in the description as well. So all you need to do is make a new repository and push your code, all of this inside a repo with the name pushups logger. So tutorials don't mind this folder. It is only a tutorial or a video wise source code which is not going to be used by Heroku. But everything else is the same. So license is just an MIT license for this. Icon is something I need to delete. Let me just do it right now. I don't have to look at it every single time. Yeah, just a second, guys. Yeah, so we have a README, we have app.py, which is the same as we did. We have our requirements, we have pushups logger, which has everything which we have made. And now that you have this here, we are all ready to go and deploy our website. and we can do this in like really simple steps. So first, as I said, create your own Heroku account and go to the dashboard slash apps. So I just have one app running since a month or so. So we'll create a new app. So go to new, go to create new app, give it a name. So let's see if pushups logger is available. So it's not. So let's go to pups logger. Please choose a better name than I did. I'm really sorry, but pups logger it is. And let's say create app. Now your app is created and you need a way to deploy it. So as you can see, we can connect our GitHub account to it. So since I'm already logged in, I just click on GitHub and it connects my account here. But it'll just have you log into your GitHub and authorize GitHub and Heroku just to make sure that there's nothing in between. And enter your repository name. So my repository name is pushups logger. So pushups logger and I search. And here it is, and all I have to do is just type connect and wait for this to connect. Now we have some options here, so something called as automatic deploys. So basically, whenever you add a new commit to your GitHub repository, you want Heroku to automatically deploy the web app with the new commits. So for example, I added a new feature on my application where you can not only track your workouts, you can have people comment on your workouts. So once I add this inside my app, all I have to do is commit the changes and they'll be automatically taken in by Heroku and deploy with the new features. So that is what if you want it, then click automatic deploys. I do it anyway. And which branch do you want to deploy? So we just have a master branch here, nothing else. So we'll just say deploy branch and let's see what we get here and how is Heroku working with this. So first Python app detected because we had the Gunicon. Then we use requirements.txt, so it's downloading all of it, downloading the Python platform first. Then we have SQLite, all of the requirements that we want, and some requirements that are required by our requirements. So all of that is happening right now. And let's wait for this. So we have downloaded all the packages which we need to deploy our application. It's just going to take like 3 more minutes now and we'll be good to go. So yeah, let's wait for this to run properly. Then yeah, so proc file declares type web. So now Heroku knows that it's a web application and it has to use Gunicon to deploy it. It's compressing, it's launching it now, and we're good to go. So we have pubs.logger.heroku deployed to Heroku. So now we can actually deploy see our application in action. So just refresh this once. And let's just make sure that everything is up and running. So activity, it is deployed successfully. So click on open app. And as you can see, our web application has been hosted on the internet using Heroku for free. So pubslogger.herokuapp.com is our website. You can go and check it out for yourself, and it will be definitely running from your laptop as well because it is deployed to the internet. And again, you can go to all workouts, you can create your workouts, you can sign up, you can log in, you can do all sorts of that. You just play with it, add some analytics, add some graphs. You can see your activities here, you can see the overview. As you can see, it is completely free, there is no cost for it. You can see the resources it's using, nothing else, free dynos, how to deploy it. We have been using it via GitHub, so it's very easy to do it by GitHub. And yeah, so this is how you can deploy your application on the internet using Heroku. All you need to do is have a GitHub account, push your files and your folders inside a repository, then make sure it has app.py to locate the app, requirements.txt and a proc file, and then you need a Heroku account where you just go to the dashboard, go to create new app and follow the steps, and your app will be ready. So yeah, this is how we do it. We have successfully made a simple Flask application which performs all the minimalistic features a Web 2.0 web app has to perform. And the next set of playlists and tutorials will talk about how we can create a REST API, only a REST API using Python and Flask. So yeah, until then, thank you guys. We are going to make REST APIs using Python and Flask, and we'll also talk about what kind of APIs we're going to build, what is REST, what is API, and we'll just cover the basics of building REST APIs in this video. And in the upcoming videos, we'll actually start coding up our APIs using Python. So let me just show you what the final goal or the final API is going to look like. So just give me a second. So, API, we have our server running, and we'll be using Postman. Let me just show you what Postman is. So for all our to check whether our APIs are working or not, we're going to use something called as Postman, which is a collaborative platform for API development. So make sure you have this downloaded. It's free to download this, and the link is postman.com. And you can use this. We'll be using this to actually build our API and see whether the API is working or not. It's pretty simple and pretty easy to use. Let me just show you what it is. And it doesn't take much time usually. And yeah, we're good to go. Awesome. So this is how the API or Postman looks like, and just don't worry about everything else. We'll be looking into all of this a bit later. If you want a dark mode, go for a dark mode. It looks pretty cool. And let's see what we have. So click on new request, and just click on new request, which is going to be an untitled request. And now we have our local host running, and we are going to develop an API for a to-do list app. So a to-do list app has a lot of features where you can add your tasks to the to-do list, can update your tasks, and you can delete your tasks in a to-do list app. So we're going to make an API which handles all of this, handles how to add your tasks, how to update your tasks and delete your tasks. But we'll only be developing the backend or the APIs for it. Let me show you what that looks like. So let's just see all the to-dos which we have. And we have none now. So let's add some. So we add one. And you don't have to worry about what all of this is for now. I'm just showing you the final stage. So the task. The task is going to be one-on-one session with Donna on the weekend, and the summary is going to be talk about Python job / internship prep, etc. So we have this to do which you have to complete on the weekend, and we press send, and it's added to our to-do list. And now we can go to get and /todos and see that it has been added. We can add another one. So let's say 2, and let's say subscribe to programming knowledge, and with the summary being go to YouTube and do this, and we add this as well. It has been added, and to check whether our to-dos are there or not, we go and see that they are. And now let's just see delete for now. So send, and Let's check whether it's deleted or not. And as you can see, it has been deleted. So this is how our final API is going to look like, where we can send requests to our URL and we can get the information. So now, before we get into the development of APIs, let's just talk about what an API is. So API is the acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. So here we are talking with our backend using APIs. So we have made our API to talk to our database, where we add our tasks, we update them or delete them. Now, each time you use an app like Facebook, you send a message or check the weather on your phone, you are using an API, or you're using a way to communicate between two applications. So let's just see an example. So when you use an application on your mobile phone, the application connects to the internet and sends the data to a server, let's say Facebook. Then the server retrieves that data, takes the data, interprets it, performs some necessary actions, and sends it back to your phone. So this can be an example of creating a post on Facebook. You send the data of your post, the server interprets the data, performs the actions, and sends it back to your phone. So then the app that interprets your data and then presents the data in a readable way. So once you create your post, you can see your post on your timeline. And this is what an API is called, and this is what happens via an API. Now that we have a very basic understanding of an API, we come to the next concept, which is REST API, or REST stands for Representational State Transfer. Now, this is an architectural style which basically defines a set of constraints to be used while creating these web services. So now these web services have to conform to the REST architectural style, and they're called as RESTful web services, and they provide interoperability or a communication between the computer systems or your server on the internet. So they allow you to access and manipulate representations using web sources in a uniform and stateless manner. So we'll talk about what stateless means. So all we need to know is that REST is an architectural style which has a set of constraints we need to use when we create these APIs. Now let's see some basic REST concepts. So first is stateless interactions. So a REST service does not use login sessions or store any information on the server. There is no load on the server, but instead the client maintains the information about each resource, which makes REST service easier to use across load balance servers. So if you have multiple servers, where if one server crashes, you can use another server to present your data to the client. You don't have to store any login sessions on the server. The client will be maintaining all of that. Now, we talked about a set of constraints, right, which we have to follow. So these are those constraints where we have a way to communicate over HTTP, which is the hypertext transfer protocol of the internet. So first is get data. So how do you get data from the server? Next is post data, or how do you actually send data to the server. Put is how you update that data, and delete is how you delete the data from the database. So these are the four things which we are going to have in our API and create and code them out in the next upcoming four videos, and we'll see how this works. So to actually make our APIs in Python and actually write the code for them, we'll be using something called as RESTful. So Flask RESTful is an extension for Flask that adds support for quickly building REST APIs. So it is a lightweight abstraction that works with your existing object relational mapping libraries. So it works with Flask seamlessly. It also encourages best practices with minimal setup. So we'll have only a single Python file, just one .api file. We'll be creating everything. And since we already have talked about Flask in our previous playlist, so we had developed a push-ups logger web app using Flask in the previous playlist. So once we are familiar with Flask, this should be very easy to pick up. So again, to install Flask RESTful, you have to follow this pip install Flask RESTful, And also make sure that you have Flask. So pip install Flask as well. And let me just do that right now just to show you how that looks like. So quickly install Flask. I already have it. So the next thing is quickly install Flask RESTful. And yeah, so make sure that you have all of this and you have Python 3 as well. And let me just show you how it's going to look like. So all we are going to have is one database and one API.py file. That's it. So we are going to develop this API, which is a very common example when we start learning about REST APIs in general, how to create them. One of the most basic examples is a to-do list app or a to-do list API where we can get the APIs, create them, delete them, and it is actually do update as well now. So, so we have one, and let's update it. So now I don't want to update the task. The task is going to be a one-on-one session with Ronak, but the summary is going to be email him to set the call. And I can click on send. Okay, oh sorry, the server is not open, my bad. Okay, yeah, now the server is open and running, and yep. Now when we see all the tasks which we have, you can see that the summary has been updated. So this is what we're going to do. So in this video, we're going to jump straight into the code and see how we can start building our API. So in this video, the second video of the next three videos, total of five videos. In this video, we're going to talk about a simple basic hello world using REST APIs or using Flask RESTful. So let's see how that looks like. So first, we need to open a text editor of your choice. So it can be anything. We just open that here. And now make a folder called as to-do underscore API and create a new file into that called as api.py. Now first we need to import Flask and Flask RESTful. So make sure that you have Flask and Flask RESTful installed. I showed you how to do that in the previous video. So let's make sure you have both of them. So from Flask import Flask and from what do we need? We need Flask RESTful import. So we need two things. So we need resource, which is going to handle our API, and we need the API class to actually instantiate our API. So okay, now we have the two basic things we need to start building our REST API. So let's initialize our app. So app equal Flask name, and we need to initialize our API. So API is going to be API of the app. Now we have our basic API ready. So let's just start the server first. So if name equal to main app.run, and we'll just put debug to true. So yeah, we have our basic app ready, which is going to be running as a server at localhost 5000 port 5000. Now let's start building our app. So our app is going to have two endpoints for this Hello World program. So every single API, every single endpoint, a URL endpoint. So slash to-dos is an endpoint, slash to-dos slash one is an endpoint. So slash two, slash three, anything. So these are two endpoints which we'll be having inside our application, where we can use 1, 2, or 3 to actually see or interact with a specific task in the to-do list, and slash to-dos will be an endpoint to see all of our to-dos, all of our tasks which we have. For now, for the hello world program, to see how all of this works, we're going to have two endpoints. So we actually have our endpoints written using the add resource function. So first is going to be hello world, and it's going to be slash hello world only, and the next is going to be a name. So instead of saying hello world, we're going to say hello name, and this is going to be hello world slash. So the name is going to be a string. So this is how we actually uh, make sure that the URL accepts a string. So with these two symbols, you have string, and the name of the variable is going to be name. So now we have our two endpoints ready: hello world and hello world slash name. So here, when you have localhost 5000 slash hello world, we want we want the API to give us hello world as the result. So when you do a get to this endpoint, we need a hello slash world string to be given us, and when you do a hello world slash, let's say, run, we want the output to be hello run. So this is what we're going to build today. We're going to have two get requests. One is going to be a simple get request, which is going to be pretty straightforward, which is slash hello world, and second is going to be where we pass arguments to our API. So this is an argument which is going to be a string of the variable name. So we're going to pass these arguments and see how we can get the results back from the server or get the data back from the server. So let's build our API. So first we're going to have hello world, and we're going to inherit from resource. And as these two are going to be get APIs, we have a function called as get, and this is going to take in nothing. So it's just going to show us hello world, right? So we just have to return something when the server gets a get request, and make sure that the what you return is serializable. So we're going to use JSON, JavaScript notation, to actually return all of our information. So we're going to return the data to be hello world. So whenever the user sends a get request to slash hello world, he's going to get the result as data hello world. So what is happening here? So first, the URL is seen that you have a slash hello world. Then there is a call given to the server where you go inside this get function here, and if there are any parameters, then the parameters are used, or else you just return data as hello world. Now we need something called as hello name, where we are actually able to pass a parameter in a URL and see if that works or not. But before that, let's just run our server and see if the API is working. So I'm just going to comment this one for now. We're going to see if hello world is working or not. So we're going to see how sorry, we're going to use Postman with this. So let's run our server first. So sorry, let me go inside tools and Python 3 API py. Okay, now our server is up and running at this location. So now let's create a new request. It's going to be get and localhost 5000, and it's going to be hello world. So this is what we had here. Let me see if I can. Yeah. So now it'll just be easier for you to see. So localhost 5000 slash hello world, and we sent the request. And as you can see, we got the data as hello world, and here we got a status 200, which means that okay, our request was handled successfully. We'll talk about these status codes in the next video, but for now, we had sent a get request to hello world via HTTP,
and we got the body as hello world. Now let's build the second one, which is going to be our hello world with a parameter. So class hello name, right? So hello name. Again, we're going to inherit from resource and get self and name. So since we are passing an argument with the variable name, we have name here. All we have to do is return data. Instead of hello world, we're going to do hello and dot format name. Sorry about that. Yeah. So now let's just get this view. Yeah, and yep, the server is running. Now, what did we do here? So for every single URL endpoint, you need to have a new class, which is kind of bad. So I was thinking of doing something where, since we have slash hello world, I wanted to mix both of them into one single class, but I was able to see that we cannot do it. So for every single URL endpoint, you need a class of its own. So now we need a hello world slash string. So now, when you pass something here, so for example, give me a second, yeah. So if you pass get localhost 5000 hello world slash Ronak, the name variable stores Ronak as a string, sends it to this function, get function, and then you can use this anywhere inside your function to do anything you want. This is how it works behind the scenes. Now let's see if this works in action. So now we have a get request but to Ronak, and we press send. And as you can see, we have our data hello Ronak here. And again, if you want anything else, so let's say uh, programming. Sorry about that. Programming. You press send, and you get hello slash programming. So this is how we can send get requests to our server and also have a parameterized get request sent to the server. So we'll be creating tasks using the tool using an API which we'll be creating on our own. We'll be updating those tasks and also deleting them. And you can also have a way to get those tasks back to us using the API. So this is what we're going to do in this video and the next upcoming two videos. In this video, we'll be making our get and post request in our to-do list API. And in the next video, we'll talk about the put and delete request. And in the final video, we'll actually integrate our API with a database that can be used, which can be again then deployed and be used by everyone around the world. So let's get started. Let's start preparing our to-do list API. First, let's go into our application where you're making it. So it was, I think, to do API, and let's open up our code. And here it is. So we had made a hello world program before, but I've deleted the hello world part from the code, and we just have a very simple Flask server with an API object instantiated. Now let's see how we can make our to-do list API. So first, we need the endpoints. We need URL endpoints for our API, right? So let's say API.add resource. This is how we add our API, and each API is going to be, each URL endpoint has to be a class in itself. So this is going to be slash reduce slash integer, and it's going to be to do ID. So this is how we are going to access each and every task in our to-do list using a to-do ID or a unique ID which is associated with each task in our to-do list. So now let's go ahead and make our class, which is going to be to do, and we are going to inherit from resource again. Now we are going to make a get and post request for this video. So the get request to get that particular task using the task to do ID, and post to actually send our data back to the server, or send our task, or save our task in the server. In the fifth video, we'll be saving it in a database, but that is what we're going to do today. So let's have a get request which accepts to do ID as an argument, and now we have to return something, right? So we have to return something here, and that something is going to be the task which we can access using a to do ID. So let's make our interim database. So basically a way where we store all of our to-do lists. So it's called to-dos, and we have to always return something that is serializable, basically in JSON format. So a very close mimic of JSON in Python is dictionary. So we're going to make a dictionary and then access our task and our data using that dictionary. Sorry about that. And yeah. Now, our to-dos database. So this is going to be an actual SQL database in the final video, but now we're just going to work with a simple Python dictionary. This is going to be in this format. So we'll have the to-do ID. So let's say 1, and each to-do ID is going to have the task, and the task is going to be of two. Is going to have two keys. So one is going to be task, which is, let's say, going to be write hello world program, and it's also going to have another key which is going to be a summary of the task. So let's say write the code using Python. Now each of our tasks is going to have a unique task ID here, and is also going to have the task dictionary, which is going to be having two keys, the task and the summary. Now all we have to do here is return the to-dos by the to-do ID, and this is how we can actually get our task back from the server. Now if you see here, we are actually returning the dictionary inside, or the value in which to-do ID is the key. So the value here is this piece of data, and if you see, this is already in a dictionary format, so it can directly be returned using the get request, and we don't have to serialize it any further. Now let's see this in action, and let's see if our get API actually works. So now again, we need to use Postman to actually see if we are able to get a request successfully or not. It is the easiest way to do it. So just give it a minute. It should open. So we had talked about Postman in our previous video. I had gone through very simple basics of Postman. We are not going to be using Postman in a very complicated format today. So yeah, let's wait. It shouldn't take that much time. It usually doesn't, but I don't know why it's taking a lot of time today. No problem. Should open right now. I really need to change or update my laptop, but yeah, we're here. So awesome. Now let's run our server first. So api.py. Let's just save it again. Sorry. And yeah, now we can access our task 1 using this URL endpoint, which is /todo/end. So we do /1 and press send, and we get our task, which is the task write hello world program, and the summary being write the code using Python. Now this is how we can get our task using our task ID, and now let's see how we can get a list of all of our tasks. So now we need to have a URL endpoint where you can get a list of all the tasks. So let's make more than one task here. So let's say 2, and let me copy this, and let's also have 3. So now you have 3 tasks. So let's just say this is task 2, and this is task 3, and the summary, let's say writing task 2, and the summary for this is going to be this is task 3. Now this is how we write our tasks, and we need a way to get a list of all of our tasks, right? Because we usually don't just see one single task. We want to see a list of all of our tasks in a to-do list, and then we can work with it. So now let's have another URL endpoint for this, and let's call it to-do list. So each endpoint is going to have its own class. Let's say slash to-dos. That's it. So slash to-dos will give us a list of all of our to-dos tasks, and to-do slash to-do ID is going to give us the particular task. So let's just implement it right now. To-do list, inherit from resource, and all we have to do here is return to-dos. So, oh sorry, my bad. We need get, and then we return to-dos. Now, as you see, we just have to return a list of all of them, right? And they are already in a Python dictionary, which is serializable by the server. So now what we have to do is run our server again, and just have slash to-dos here, nothing else. Press send, and as you can see, we get a list of all of our tasks. And that is how we have a get API for our to-do list API program. Now, next thing which we have to do is have a way to send a task to the server, or actually write a task, right? So this is something which we're going to do using a post request. Now, for a post request, you can just click here and go to post, and our post request is going to have a body. So basically, the body is going to be the task and the summary which we want the server to accept. And we want to make sure that the format is always like this. So it is in JSON format, and it is going to have a task and a summary key where the value is going to be string. So we want to let Flask know the kind of data we're sending back to the server. So we need to parse that data, parse the body, and then add it or append it to our Python dictionary. So for that, we need to have a request parser called as recparse right here. So using recparse, we can add two arguments, which is our task and summary, to the post argument body, and then use that to append to our to-dos dictionary. So let's write our request parser now. So let's say task post args is going to be recparse dot request parser. Now let's add our arguments. So task dot add argument. The first is going to be task, and it's going to accept a type string, and the required is going to be true. So it is compulsory to add a task, and when a user is not able to or has not done that, then we are going to have a help here which is going to say task is required, so that the user knows what to accept and expect. And the next thing which we need is the summary. So again, a summary argument, type string, and we need a summary of our task. We are not going to make our tasks blindly. We need to add some context to our task when we have a to-do list. And yeah, so now we have a way to parse this body when we send it to the server. We have to now make use of it. So let's have a post request, self to-do ID, and now we need to accept our arguments. So args equal to task post args dot parse args. So using this function parse args, we can actually get our JSON data into our server. So now the args variable contains a Python dictionary with task and the summary. And now all we have to do is first check whether our task is already there in our to-dos list or not. If it is there, then we show an error and we abort the process. And if the task is not there, then we append the task to our to-do list. So first check if the task already exists or not. So if to-do ID in to-dos. So if the key to-do ID is already there, then we abort. So abort is again a function by Flask RESTful. So we abort. We send a 409 code, and we just say task ID already taken. And if there is no to do ID or no new task of the same ID, then we append it. So we just do to do ID is equal to so we have our task and it's going to be args task, and we have the summary. It's going to be args summary. So this is how we append our tasks to our to-dos Python dictionary. Now this dictionary is going to be static. It is not going to change or keep adding data to it every time we close the server, because it's a Python dictionary. It's going to get instantiated every single time we run the server. So in the fifth video, in the final video, we're going to actually migrate our dictionary to an actual database, which is then going to store our data in a long-term manner. But for now, let's see how we can add or send data or post a to-do task. So yeah, our server is still running. So we have everything ready here. And now let's first see how many tasks we have. So we do a get and we press a send, and we have 3 tasks now, 1, 2, 3, as you can see here. And now let's add a 4th task. We have post to /4 and the task, and we go to raw JSON, and this is the body, task and summary. So this is the 4th task and the 4th task summary, and we press send. And my bad again, we have to return something, right? So let's return the same thing which we have added. So to do ID. Now let's do it again. So I'll be closing the server so that we have only 3 tasks, and then we run the server again. And now let's add our 4th task again. So press send. And as you can see, we have added our 4th task. And just to confirm that we have, go back to /todos, do a get request, and you can see 4 tasks here in the output body. So this is how we have a post request, or we send data from the user to the server. So we have a post request, we have a request parser, basically, which accepts 2 arguments, task and summary. Then we take those arguments here to the server, and then we append it to our database if it does not exist, and if it exists, then we see the task ID is already taken. So this is how we have finished the get and the post request in our to-do list API. In this video, we'll talk about how we can update our tasks using the put request and delete our tasks. So we'll be doing this in this video. We'll be implementing put and delete, and in the next video and the final video, we'll actually integrate a database with our to-do list API. So let's get started. Let me open my code and see where we were before. This is where we were in the previous video, where we had implemented the get and the post request. So now what we are going to do is, under the to-do class, we're going to have 2 more requests where we can delete or update a task using the to-do ID. So first, let's implement delete, as delete is very easy to implement, and we can get that done in a really small fraction of time. So for delete, all we have to do is have a delete function with self and to do ID of the task we want to delete, and we just have to use del to-dos of the to-do ID, delete the key value, and then return all the to-dos. And this is how we directly delete our tasks, individual tasks, using the to-do ID, using the delete request. Now we have to implement the put request, where we actually update our tasks using the REST API. Now let's do that. So put self and to do ID. Now, since we are updating a task, we need to send some information to the server, right? So again, we need to parse our request and make sure that we have a specific way or a method in which we can edit or update our tasks. So we are going to make another request parser for the put request. So task put args is equal to request dot request parser. And now we can add our two arguments which we have had before, but there'll be a slight change. So now what we have to do is we people can either update the task or the summary or both. So it is optional to actually update your tasks. So we have to remove the required parameter from here, and we have to modify the help part as well. So for update, we will not have a help parameter because the user knows what he wants to update. So we'll just accept a string with task or summary, and we should be good to go. Now that we have a request parser, what we can do is implement the code to update our to-do list with the arguments which we get. So similarly, as we did in post, we do args equal to task, sorry, put args dot parse args. So now args contains what we need. So first we check whether the to-do ID is in to-dos or not. If it is not in the to-dos database, then we cannot update what is not there. So we abort and we see that the task does not exist. So we cannot update the task. If it exists, then we have to check whether it is a task update or a summary update and then update accordingly. So let's implement that now. So first, if to-do ID not in to-dos, then we abort with the request 404, the not found status code, and we give a message which is equal to task doesn't exist, cannot update. Now, until this line of execution, we will make sure that if there is no task, then we abort the request. But if there is one, then what do we have to do? So we have to check whether we are updating the task or the summary and then update it accordingly. So let's go ahead and do that. So first check whether if it's a task. So if args task, so we're checking if the task key exists in the args dictionary. If it doesn't, then the person is trying to update the summary, or else it's trying to update the task. So let's update the task now. So to-do ID task equal to args task. So we're just changing the task key value pair for the to-do's ID when we change the task, and we check again for summary and do the same thing, but for summary now. And in this way, we have actually updated our task, and we just return the task with the task ID. So to-do's to-do ID. Now let's see what we have done here and what is happening in the to-do list editing section. So we have a put request where we use the put request to edit a task with the to-do ID. First, we make a rule, or we make a request parser to see the way in which we want to accept our data. So we're going to accept two arguments, task and summary, task or summary, where both of them are optional and nothing is required because we are editing whatever you want and whatever you feel like. Then we parse these arguments and first check whether to-do ID is there in the to-dos database or not. The database here being the to-dos dictionary. So first we check whether the to-do ID exists. If it does not exist, then we abort the request. If the to-do ID does exist, then we check whether we are updating the task key or the summary key, and we update the database or the Python dictionary here accordingly. And then we return the task which we had updated in the output. So this is how we have almost finished our REST API implementation with Python. In the next video, the most important video is where we'll be actually uh, adding our database, SQLite database to our REST API, just to make sure that the entire implementation is complete. And we might also have a sixth video to actually host our API, and then we can use our phone or our laptop to check whether the API is working or not. But for now, we have finished implementing get, post, put, and delete request using our REST API. And let's just see it running first. So before we end, let's see if we can have put and delete running. So let's save our code and run our server. The server is running. First, we see our to-do list, so a get for to-dos, and we have three. So let's edit task three. So we do /3, and we do a put request with the body in JSON, and we just update the summary and not the task. So the summary is going to be that updated third task summary. So now the current summary for the task 3 is this is task 3, and we are updating it to updated third task summary. And let's send the request, and we get an error. So if task can do this, if not, there is no task, and we make sure that there was no task. So let me see what the problem is here. There is no key error, that is the point. Just make sure that our request parser is also correct. So I think I know what the problem is. So let me just put this in double quotes and also put summary in double quotes just to be sure. Now just check it once that we have everything which we need. So we have oh, I get it. So yeah, my bad. We do a put and we run a put, and we do a put again, not a post. Cannot assign literal, so this is going to be task. Summary. So I don't see what is problem here. Unexpected token. Where? Just a minute, guys. We'll just try this again, and we should be good. Instead of update, we just have put, and put. And here as well, we just change it again. Task. Summary. And yeah, we're good to go. Let's run the code now. And end of line while scanning the let me see what the problem is here. I get it. Wow, I didn't realize this was a problem. But we are good to go. Sorry about that delay. This happens sometimes. And we'll make it task. And yeah, now we'll be good to go. Okay, so let's update task 3. And we have updated task 3. Then we can go to get all to dos, press send, and we have task 3 updated. Now let's try to delete our task 3. So go to delete to do /3 send, and as you can see, we just have 1 and 2 tasks right now. So this is how we implement a REST API using Python and Flask, and all we have left to do is actually save our tasks into a proper database and not a Python dictionary. So in this video, we're going to do just that. We're going to save our tasks, to-do list tasks into a SQLite database, and then access our tasks from there as well. And in the next video, we'll talk about how to deploy our API on the internet so that other people can use it. And we'll talk about that in the next video. So let's get started. Let's start making our fully fledged REST API with the database. So let's see where we were in the previous video first. Let's see how our API works. So once we have the server running, we can first see that this is where we were. We had an API.py file and we had our tasks in a Python dictionary, and we were able to write our APIs and then access our Python dictionary by converting it to JSON because it is serializable. So now let's see how it works. So we have a get on /todos. So a get on /todos will be giving you all the tasks that are there in the to-do list app right here. So yeah, we have our hello world task. And now let's build on top of this and actually integrate our SQLite database into our REST APIs. So let me close our server and go to our file. Now, since we'll be using SQLite, we'll be using something called as Flask SQL Alchemy, which is going to help us work with the database. So let's import that from Flask SQL Alchemy, import the class SQL Alchemy. And now let's write some configurations for our database. So I already have them here. Let me just get them. And yeah, so this is exactly similar to what we had done in the Flask web application tutorial, where we have a database, we configure it to where we store our database, and we instantiate our SQL Alchemy object. And now, like a generic Flask web application, we are going to be making a model, which is going to be a way where we actually map our objects to the database. So we have a class to do model, which is going to inherit from db.model. And we're going to have 3 things. So we're going to have ID, task, and summary. So ID is going to be the primary key and the unique ID for each task. Then we have the task title and the summary. So let me just put them right here, and here we go. So we have ID, task, and summary. It's going to be an integer, string, and string respectively. The next thing which we have to do is basically create this in a database, right? Create our SQLite database. So we can do that by having a db.create all function, and this will create our SQLite database when we start our server. So we want to do that, and we have to make sure that we do this after we make our to do model class, so that all of these rows and the table can actually be initialized in the database. And yeah, let's do this, and let's actually build or actually just create our database. So yeah, Python API.py. Yeah, as you can see with the SQL Alchemy errors, you can ignore the errors for now, but we have our database inside. So as you can see, SQLite.db. So let's comment this out because we don't need anymore. We already have our database. Let's remove our to-dos from here. Actually, let's just make it empty for now. Or let's actually remove it. Okay, so now we need to add a way to use our database with our APIs. So The first thing which we need to do is figure out how are we going to actually show our data uh, or return our data to the client when there is a get API request. How are we going to return our to-do list? So we have to make sure that it is serializable. So it has to be JSON. So the best way to do is to use a Python dictionary, right? So we're going to actually mock that way of writing Python dictionaries by something called as resource fields. So resource fields are actually a set of rules that you have in which you have to return your API information. So if I want to return a JSON, I have to make sure that every single uh, API method which I annotate with the fields should definitely follow that as a rule. So let me show you what is happening so you can understand for yourself. So we have something called as resource fields is equal to first ID. So we want to display the ID, and this is going to be an integer. So the way we actually tell Flask is by using something called as fields. So we have ID equal to fields dot integer, and similarly we have the task and summary as the string. So let me just get it here. Yeah. So this is how every single return statement is going to look like. So we're going to return an ID, task, and summary, and all the methods which will be following this when they return a to-do list task. We have to annotate them with something called as marshal with. So once we annotate our methods with marshal with the fields, we can then use them and return the API accordingly. So now let's just annotate everything. So we have marshal with resource fields. Copy that. So we'll be returning this task in a get request. We'll be doing it in a post request and a put request. So we won't be doing it in a delete request because we have no task to show. So yeah, this is how we're going to actually inject our resource fields into the return statements. And now let's start writing the logic for having it inside a database. So the first thing which you're going to do is the post API. So we're not going to make any big changes here. So just very little changes, and you'll just see it right now. Nothing complicated to do. So once we have our arguments from the body of the post request, we have a task and summary, which you can actually use this to play with. Let me just show you what happens now. So now we do a query. So since we already covered this in the Flask tutorial, I'm not going to cover this again, but let's just see a bit of an explanation. So we have a task which we ask the database to give us by the to-do ID which we specify. And if the task already exists, then we cannot create the same task with the same task ID. So we abort. And if there is no such task, then we create a new object, and then we add that object to our database, commit the changes, and return that object to do. And now since we'll be returning a to do object from the database, and we want that to look like this, we want an object, a Python object, to look like this. This is where fields and marshal with comes into the picture. So with resource fields, we tell that we want to return ID, task, and summary, and the marshal with annotation actually injects that rule into our method. So yeah, this is the logic for post. Let's start it for get now. So it's going to be very similar to the Python tutorials that we had for Flask. So now here we again ask the database to filter by ID, get the first task, and if the task does not exist, we cannot get it. So we say we could not find that task, and if the task is here, then we return it. And since it is again an object, Python object, and we want it to look like this, we add a marshal with. Let's go ahead with put and see how we can change that. So put is going to be pretty similar to post, but with a little changes, or similar to this actually. So again, we get the object. If there is no object, we cannot update an object, right? And if there is, then we say the task, the object properties. So we have task dot object variables. So we have task which is going to be changed, or if there is a summary, then that is also going to be changed. And then we commit our changes, return the task, and marshal it with resource fields. The last is delete. So again, pretty straightforward, nothing complicated to do here. We just have task equal to model.query, we say delete task, and we're good to go. And now we have finally added everything to our database, but we have one left, which is the another URL endpoint. So this one, we need to write something to get all the tasks, not just by task ID. So this is what I will do, but in a different way. So we're not using Marshall with resource fields here, but an actual Python dictionary, so that we can understand how this actually can work both ways, with and without resource fields. So here we do a query for all the tasks. Then we have a Python dictionary, and we just populate that Python dictionary with the task objects that we have, and we return that Python dictionary. And since Python dictionary is already serializable, we don't have to worry about marshalling it with any of the fields. So yeah, this is how we write our APIs, and let's run and see if this works or not. We have Python API.py. Oh, my bad. So return is outside function. Where? Line 40. Let's go to line 40. Oh, sorry, we don't even have a get request here. Wow. And yeah, that was my bad. And we will do now. We have our database ready. We have, let's just see if we have commented create all. Yes, we have. And let's actually make our first call. So we do a post with a body. So let's say task is going to be task 1, and the summary is going to be task 1 summary in JSON format. And if everything works smoothly, then this should work. And let's hit send. And yeah, so we have a few errors. Give me a second, guys. We'll fix them up right now. So yeah, let's create our database again. Might be some mistake with that. Happens sometimes. Don't have to worry about it. We do this. We reload, and we should have a DB. Great. We can comment this out. Save it again. And the server is starting again. And we're good to go. So let's try this again. To do /1 send. And see, we were able to actually add a task to the database. And now let's actually add another one. So let's say task 2 summary. Alright. And we have /2. Let's add task 2. We will add that as well. And let's get all the tasks now. Get to dos. No body, please. And hit send. And yeah, we have task 1 and 2 here. Now, the difference between using a Python dictionary and database is that now, even after we close the server and open it again, we'll have all of our 2 tasks ready here. So before we finish this video, let's actually just test put and delete. So put /1. I'm going to put a body. So I'm going to change summary and updating. Summary is going to be task 1 summary updated. And hit send, and it is updated now. And we can also delete it the same way and press delete, and yeah, we're good to go. So this is how we make a REST API using Flask and Python. In this video, we'll talk about how we can deploy a Flask REST API using Heroku onto the internet so that other people can use the API as well. We'll see how we can have a Flask API which was built using Flask RESTful and then deployed using Heroku, but we also have a SQLite database which is integrated with the API that will be deployed on Heroku for the internet to see. And to test whether the API has been deployed on the internet or not, we'll be using Postman to check and do some API request calls, for example, a GET request or a POST request, to see if our API is working properly or not. So let's get started. So first, I have set up an API uh, code base where you can see how the API works. And in this video, I'll only focus on deploying that API. So let me just show you how the API looks like. So here I have an app.py file, a very simple, basic Flask application, RESTful application. And here, let's just go through the code once before we actually start with the deploying steps. So here we have Flask RESTful and Flask Alchemy, which we'll be using along with Flask, and we will be deploying a to-do list API where you can do a bunch of calls to the to-do list API. For example, create a to-do list using post, update it using put, get all the to-dos using get, and also delete those to-do list tasks. So first, we set up our application, initialize all the objects that we need to initialize. We set up our to-do model class. So usually when you see a very typical Flask application, you notice that all of these models, database models, and the APIs and the code is actually separated using different files and different folders. But since this tutorial is only focused on deploying a Flask API application, I have actually culminated all of them into one single app.py file. So just bear with me there. And here we have a few request passes using which we actually make sure that we get the task and the summary back from the user when they do a post or a put request. And this is our API. So we have two URL endpoints. We have a slash to-dos, which gives you all the tasks, and we have slash to-do slash the to-do ID, which will be using an integer to actually post, put, get, or delete that particular to-do list task. So this is how our Flask application looks like. Just make sure to see that we also have our app.run method here, so that we know that this app.py file is going to actually run our server and get the API up and going. So how do we deploy this using Heroku? So the process is really similar to what we used to do for a typical Flask application without the API, REST API part. So let's see how to do that. And this is going to be done using Heroku, a free Heroku deployment method. You can do it on your own PC as well. So first, we need to make a requirements.txt file. So a requirements.txt file basically has all the frameworks and modules that your code uses in order to run it properly. So we use Flask, we use Flask RESTful, we use Flask SQL Alchemy, but we don't use Gunicon. So Gunicon is basically something which will be using by the Heroku platform to actually understand that we are running a server and the server is running from app.py file. So first, before we jump on to the Heroku part, let's see how we can actually make a request.txt, requirements.txt file. So first, let me just copy this part now. So copy, and now let's delete our requirements.txt file. So I'll be showing you a very nice way of doing this, not a pip freeze method, which people usually do, but we'll be using a different method to actually generate our requirements.txt file. So let's delete it now, move it to trash, and now let's go into our folder. Awesome. Now, what we can do to generate a requirements.txt file for this particular project. So this particular project is inside to-do API folder, and we only want to have those frameworks and modules or libraries inside the requirements.txt, which are being used inside this particular directory. So the typical way to do this would be to actually have a virtual environment inside your to-do API folder, and then freezing using pip freeze to actually get those inside requirements.txt. But since I don't feel like having to use a virtual environment for every single project that I do, so I just have a common Python environment, and then if you do a pip freeze, then it actually takes up every single library or framework which you have in your main Python environment, right? So we have something better for this. and that is called as piprex. So first we do a pip install piprex. So piprex is basically an open source project where you can actually make a requirements.txt for your particular folder only. So to do that, it's very easy. First, go inside your folder. So I'm inside to do API and just do piprex dot. That's it. Dot is basically telling piprex that we want to make the requirements.txt for this particular folder. Press enter, and we have a requirements.txt file right here. So as you can see, we don't have the Gunicon here because our app.py file only uses these three for now. So we just paste our Gunicon here. You don't have to mention the version, that's completely fine. And just make sure that you also have Gunicon installed. So just do a pip install Gunicon. To install Gunicon, and you're good to go. So now we have a requirements.txt file. So basically, we need the requirement.txt file so that Heroku can actually use this to set up the environment when they're deploying our application. The next thing which we need is a proc file. So a proc file is basically something which is only for Heroku. So this tells Heroku that we'll be using a Gunicon based web server, and we will be having an app. So it's going to be app. So we're basically telling Heroku that look for an app.py file, look for an app.py file, and when you find that, run the app inside it. So we have a Flask app here. So we want Heroku to actually run the app whenever it deploys it to the internet. So we just need these two things, these two extra things, files to actually have our API up and running onto the internet and to deploy it. So now that we have our Gunicon and we have an app.py which runs a to-do list API, the next thing which we have to do is basically deploy it. So let's see how we can do that. So I won't be going through the terminal or the command line way of using Heroku because as much as easy as it is, it's really hard for somebody to visualize what is happening behind the scenes, right? So we'll be using the web interface to actually see how we can use Heroku. So make sure that you log in and you have created a free account on Heroku. So it is free to make an account, and then click on new, create new app, give your app a name. This app name is going to be the URL as well. So let's say Flask REST API. No, somebody's already in. So test. No. Yeah. So not the best name, but we can work with it for now. Press on create app. Okay, so app name must start with a letter, end with a letter. Okay. So testing. And yeah, great. Let's create our app. And now we need to give Heroku our code so that it can run it and deploy it, right? Deploy an actual server on the internet. So instead of using Heroku CLI, we'll be connecting our repo to GitHub. So we're going to actually push the code. So we're going to push the entire code which we have here to GitHub. So we have all these files. We'll be pushing all these files to GitHub very easily into like 10, 5, 2 minutes. Just create a new project, Flask, and make sure it's public. Add a readme if you want to, and press create repository. Now to actually upload your files onto GitHub, all I have to do is just drag and drop them. So let's drag and drop them here, and that's it. That's all we have to do to actually upload our files to GitHub. So now that this is done, we commit the changes. This might take a few seconds, not minutes. So just bear with me here. Yeah, we're done. So we have all of our files here. We have proc file, which contains an app web Gunicon. Next, we have a README. So the README is optional, but it's always good to have a README file. We have a requirements.txt, which is basically all the library which you need. We have a database, so it's not recommended that you actually have a database on GitHub like this without any security on top of it. But since it's just a way to show you how to deploy a project, we'll be having it here. And we have our final app.py file, which has all the code which we need. And now let's see how we can connect it to GitHub. So just go to GitHub Connect. If you are not logged in, then it might ask you it might ask you to log in, connect to GitHub. So I'm already connected to GitHub here. User repo name, so it's REST something. So I just put REST, and it's REST Flask. So press connect, and that's it. So you actually have connected your repository to GitHub. All you have to do now is basically say deploy branch. So we have a main branch or the master branch, which is now the main branch. And all we do is press deploy branch, and we see our API being deployed on the internet right in front of us in real time. So first, as you can see, it detected that it's a Python app since we told it in the proc file. Then it's installing Python, installing everything that you need or all the libraries, and then the proc file declares the type as web. So it's a web server, a Gunicon web server, and now it sees where to actually launch it from. So this is our URL. So we have a URL ready, just deployed to Heroku. And just to make sure that this is actually deployed, we can just go and check it in the activity tab. And yeah, so we have successfully deployed our application. Let's see the URL for it. So this is the URL. And let's copy this URL, so that we'll be testing whether our API is actually there or not. And to test whether our API is working, let's use Postman. So let me bring up Postman in the middle. Yeah. So we'll be doing a get on the API, and the endpoint is to-dos. So let's send this and see what happens. We press send. You can see in the body, we already have 2 tasks inside our to-do list, and this is how we actually deploy a Flask REST API on the internet using Heroku. So now, actually, if you guys actually go to this URL and the endpoint, you can actually make some put request, get request, create request to it. So go ahead. Actually, I would like to see some tasks here. Just make sure not to spam it because it's just a hobby project. And yeah, so this is how we create a to-do list, or we actually deploy our app to the internet using Heroku. So yeah, that is it, and thank you for watching. I'll see you in the next one. In this video, we'll talk about how we can integrate a MongoDB database with a Flask REST API written in Python. So in this video, we will actually integrate or add a local MongoDB database, which will be running on a local host server to already pre-written Flask REST API. So let's see how we do that. So first and foremost, to start integrating MongoDB with our Flask REST API, the first thing which you need is MongoDB, of course. So you can download MongoDB from mongodb.com, and if you have a Mac, then you can actually just do a brew install MongoDB community, and you can get it on your machine. Now, the next thing which you want to do is have a client for your MongoDB database. So it's perfectly fine to not use a client. It's not compulsory, but it's very easy to visualize your database when you have a client or a UI client for your database. So for that, I use something called as MongoDB Compass. So Compass is by MongoDB, so it is a UI client for MongoDB database. So I use Compass when I have to actually visualize or see my database in action in real time. So we'll see how that happens. And yeah, so once you have MongoDB and MongoDB Compass, you can get started to integrate your MongoDB database to a Flask REST API written in Python. So let's first run our MongoDB server before we start anything. So in Windows or Linux, there might be a different way to start your server. So you can just Google that. But for Mac, since I'm using a Mac and I have Homebrew, I'll be starting my MongoDB server using Homebrew. So let's do that now. So all I have to do is do a brew services start MongoDB community. So it's really easy to start your server using Mac. And now that it's started, I can shift back to my repository and open the code for my REST API. So I'll give you a very brief explanation of what the REST API does and what is happening in the API, so that we can actually start. Yeah, I think it's loaded. Let's wait for the color to show up. Syntax highlighting, and yeah. So here we have a very simple Flask API written in Python. So the API is of a to-do list. So you can use this API to add tasks to your to-do list. So create the tasks, update the tasks, and delete the tasks. So it is a CRUD API where you can get all the to-do list tasks that you have. You can post them, you can put or update them, and you can even delete them. But if you see in this piece of code, our only database is basically a Python dictionary here. So we're not using a concrete database here. We're just having a Python dictionary where we store our values, and the database gets completely, scraped or vanish after you close the server, and when you run it back again, you just have one in it. So we need something concrete, and let's see how we can use a MongoDB database to actually integrate with our to-do list API and develop a fully fledged REST API or a CRUD API. So MongoDB is a NoSQL database where your database or your values are stored in the form of a document. So we'll see how what all of that means. And yeah, so let's start integrating MongoDB to our database. So to do that, the first thing which you need is something called as Flask Mongo engine. So we need a way to actually have our Flask application talk to the MongoDB server. So for that, we have something called as Flask Mongo engine. So let's install that. We'll do a quick install Flask Mongo engine. And since I already have it, already done. And now that you have it, the next thing which we need to do is basically import a bunch of stuff. So let's start doing that. So before we import something in MongoDB, let's actually import a few things here. So we'll be importing fields and partial width. So I'll talk about what these things are. And now let's first import our configurations for MongoDB. So just have a few configurations which we need to actually have our database initialized to MongoDB. So we have our config, where we tell that the database which you're going to access is to-do model. So we haven't created this to-do model yet. We'll be doing it using Mongo Compass to show you how easy it is to actually create a database. Next, we have our host. So we are hosting it locally on our on me it's a laptop. So yeah, and the port is 27017. Then we create a MongoDB Mongo engine object. We initialize it to our Flask application. And now, before we jump on to writing any more code, let's actually create our database and MongoDB. So I'll be using Compass for that. So let's just give it a minute to load. So yeah, while this loads, we can actually start writing our code. So we won't save or run the code, but we can start writing it by the time this initializes. So the next thing which we need to do is have a way for us to map our database or map our Python objects to the database, something called as ORM, Object Relational Mapping. So we need to create a class called as to-do model, which will be inheriting from db.document. And now every object, okay, so one second, yeah. So every object that is made of this to-do model class will be stored as a document inside MongoDB. So let's see what we have as our keys in the key value pair that we're going to store. So first we have is an underscore ID. So underscore ID is given by default to every single document that you create on MongoDB. But this is usually stored as an object ID, which is not the best to read or to understand. So we'll be actually overriding this ID and creating our own integer ID, which is very easy to read and very easy to work with. So let's do that first. So we'll have an int field. Next is our task. So the task is going to be db.string field required equal to true. Did I spell that right? Yeah. Similarly, we're going to have something called as a task summary, which is going to tell you more about the to-do task. Okay. So this is how we actually link our or map our objects to actual MongoDB documents. So now that we have our compass ready, let's actually start making the to-do model local DB. So once you open MongoDB Compass, you have this as your welcome screen. So since we are running the server locally, we just press connect and we connect to the again this is okay. So we have a to-do model and we're going to name the collection as to-do model as well. Press or hit create database. And take some time, but it's worth it. So yeah, let's go inside our to-do models. As you can see, the collection has no data. So let's actually finish writing our code to integrate it, and let's actually add some data into this. So now that we have written our class, now let's talk about how we can interact with the API using MongoDB. So first, let's work with post. So post is how you create a database, or sorry, create a document. So for that, we'll be doing a few changes. So I'll just show you this right here. Yeah. So first is a simple post args, so a request parser where you take in the body of the API into arguments. So if you are not familiar with how Flask REST API or request parsers work, you can watch the Flask REST full tutorial, which is available in the channel. The next thing which we want to talk about is creating a to-do object. So we have a to-do model where we pass in the ID as a to-do ID, task as the arguments task, which will be in the body of the post request, and summary. And all we have to do is do a dot save to actually save it in our database. And yeah, it's that easy. And yeah, we do an ID equal to to-do ID. So instead of doing this now, let's actually return the object that we have created. So let's just do to-do and give a status code back. Yeah, this is how we write a post request to actually get some task from the user and saving it in our database. This is the model.save, object.save, that easy. Next is get. So get is basically how we get our task back from the server to the client. So for that, we just have task equal to to-do model.objects.get. So we get it by the ID because ID is unique. And if not task, if there's no task, then we just abort and say that could not find the task with that ID. Yeah, that is it. So it's as simple as doing a get call on the objects inside to-do model and getting the to-do ID, and we just have the task here. The next thing which we talk about is going to be put, or basically how we update our database or update our documents inside our database. So let's go through every single one of these now. Just update it here. And yeah, so again, we parse our arguments, get the arguments back. And then if the user wants to change the task, then we do a get on the to-do ID. And we just do a dot update method call. And that's it. So we just do a method, update call, and we pass in the arguments that the user or the client wants to change. So for example, if I want to change only the task of the to-do list document, I just pass in the task arg, and if I want to change summary of the task, then I just pass a summary argument and change the summary directly with just one update command. So yeah, pretty simple, pretty straightforward, nothing complicated here. The next thing which we have is delete. So delete is how you delete the document inside MongoDB. So again, we do a to-do model.objects.get underscore ID, created by the ID, and call the delete function, and that's it. We delete our to-do list task. We just do something called as task deleted and send a 204, which is for delete. Great. So this is how you write basically or integrate MongoDB with Flask. It's pretty straightforward. Nothing magical here. So we just have very simple APIs. So since we are using Flask Mongo engine, it makes it really easy for us to make CRUD applications. So we just do a get on to-do ID, get the task, return it, then do it again. Make an object, do a dot save to save it to the database, do an update, and do a delete. So pretty simple function calls which we have here to integrate our Flask API with MongoDB database. And now we just have to make a few changes here. So let me show you what those changes are. So we had imported fields and marshal with here, right? So now what are fields? So when we return something back to the client, as you can see, we are returning a task, right? And a task here is a to-do model object. So when we return a response back to this client, it has to be serializable or in a serializable format. And the most commonly used serializable format is JSON, which is JavaScript object notation. So we have to make sure that everything that we return is in serializable format. So that is where fields come into the picture. So we create something called a resource fields where we have an ID, task, and summary. So whenever we return a to-do model object, we want it to look like this, and Flask helps us do that with something called as marshal with. So marshal with basically adds this set of rules, resource fields to our uh, methods, and whenever we have that as an annotation, whenever we return an object, it is converted into this form: ID, task, and summary. So this is how we actually use fields and marshal with, a pretty cool feature of Flask RESTful to actually return back our objects in a serializable format. So now that we have our Flask application ready, let's run this and see how this works. So to see whether it's working properly or not, we have Postman, which is going to help us send the request back to the server and see whether it's working or not. So let's run our server first. So we do a Python API.py. We have a server running. Let's see if we have created a to-do model. Yes, we have. And let's do a post to to-do/1. Give it a body. This is task 1. And the summary is also task 1. And send the request. Okay, so it doesn't show what you have sent, but when you see the database here, hit refresh, you can see that we've actually added our to-do list task into the database. And it's pretty easy, pretty straightforward to see how this works. So let's do it again. Let's add another one. So let's add task 2, do task 2 and somebody else task 2, hit send. And now let's see our database again. Hit refresh, and as you can see, we have our task 2 in the MongoDB database as well. So yeah, this is how you integrate a MongoDB database with a Flask REST API, and you use MongoDB and MongoDB Compass as the UI client to actually visualize or see your database in action. So yeah, that was a tutorial on MongoDB integration with Flask. Thank you for watching, and I'll see you in the next one.